Okay, good afternoon, dignitaries and students. I guess I'm audible now.
Yes, audible. We can start.
Good. Indian Institute of Space Science and Technology, in association with Sargakshetra Cultural, Academic and Charitable Center, managed by CMI Fathers, has organized IIST at the Rate Schools Program 2020, titled Beyond the Horizon. It's a 5 days program which begins now with an inaugural ceremony. Let's begin this inauguration session with a silent prayer. Father Alex Praikulam CMI, our beloved Director of Sargakshetra Cultural, Academic and Charitable Center, is here with us. He will be addressing, welcoming the gathering. Father, please.
Okay. Yes. A warm good afternoon to one and all.
Yes, Father, you are audible.
It is with great joy that Indian Institute of Space and Science and Technology and Sargakshetra organized this webinar series for the students from class 10th, 11th and 12th. Sargakshetra is an academic, charitable and cultural center established in the year 2002, inspired by the vision and heritage of St. Kuryakos Elias Chawla, one of the founding fathers of CMI Inauguration. The CMI fathers have been actively engaged in providing holistic and integral development to individuals through education and socio-cultural activities. Sargakshetra undertakes various activities in 3 different sectors: charitable, cultural and academic, with a motto, a better person for a better society. The Sargakshetra also has previous history of organizing workshops for the students to motivate them in subjects related to space science and to offer them opportunities to interact with great scientists and academics of IIST. These workshops also help the students gain knowledge in laboratory experience and space observation. With a great privilege, I now welcome the dignitaries for their valuable presence. First of all, let me invite Professor B.K. Dadwal, Director IIST. It is not the very first time that Dadwal sir is associating with Sargakshetra, and so I can assure you that his presence will be a great help for you students. I now welcome Professor Kuribula Joseph, Dean, Student Activities and Welfare, IIST. Kuribula sir has always helped Sargakshetra organize various workshops for the students in association with the IIST. Let me now welcome Professor Krishnamurthy sir, Registered IIST, and for Sebastian Teacher CMI, Patron Sargakshetra, for their wholehearted support for the success of this program. It is now time for me to welcome the program coordinators, Dr. Shaijuman CS, Assistant Professor IIST, and team members of Sargakshetra who helped organize this beautiful platform for the students. Dr. Legin Muriel Siamai, Ms. Marina Sibi, Ms. Jeffin Jo Thomas, and Mrs. Nimmi Joseph had offered a lot of support in organizing this program. I welcome all of them. Last but not the least, I welcome all my dear students to this webinar series. Hope this program will be helpful to each and every one of you to develop and interact with this space and science. I wish you everyone a wonderful session. Thank you.
Thank you, Father. Professor Kuruvilla Joseph, PhD, FRSC, doing research in the field of nanomaterials, polymers, and composites, and has headed the Department of Chemistry at Indian Institute of Space Science and Technology, and is presently the Senior Professor and Dean at the Institute and Welfare IIST. He has done postdoctoral at the Federal University of Paraíba, Brazil, and Swedish Institute of Composites, Sweden. He did PhD from the Regional Research Laboratory, CSIR, Thiruvananthapuram, in collaboration with School of Chemical Sciences, Mahatma Gandhi University, Kottayam. His H index is 51 and item index is 155. He has more than 11,000 citations to his credit. Besides, he has published 4 academic books by international publishers as author, editor, and published 25 book chapters, and he has been invited as speaker for hundreds of national and international conferences. He has 3 patents and more than 200 publications in international journals. The academician has produced 20 PhDs and several master projects. He has also been deemed worthy of several esteemed awards and honors. Professor Shiva Prasad Award 2000, the Young Scientist Award 2000, the Matthias Award 95, the Highest Certification of Merit 94, Young Scientist Award 93 are just few of them. With so much of proudness, I invite Professor Kuruvilla Joseph Sir to tell these little students about IIST at the rate schools. Sir, please.
Hello. Yeah, thank you so much for the nice introduction. I am extremely happy to participate in this 9th edition of IIST at schools. In fact, we conducted one IIST at school program in association with the Sargakshetra 2 years back. Our director and all faculty members attended the program. It was an excellent program. That's why when you have requested us, director was very happy to accept the proposal. And you know that over the 5 days of this IIST at school program, we are going to demonstrate various aspects of space, science, and technology. Starting from the talk from Dr. V.K. Dadwal, the director of IIST, followed by Dr. Y.V.N. Krishnamurthy, the registrar, and these 2 people were really worked with the Indian space program in a different various levels. A director of NRSA, director of IARS, and a lot of activities. So the students are getting a real hands-on experience on various space applications, space programs, and things like that by hearing these 2 world-renowned space scientists. Followed by, we have another 13 demonstrations and followed by lectures by eminent faculty members of IIST covering various areas of space science and technology. And those who are registered for this program really lucky to associate with this IIST school program. What I understood is that over 1,500 students are registered across the country. And I wish all a fruitful discussion throughout the program. You may please interact with the faculty members, scientists, and you may get a very clear, good clear idea about IIST as well as Indian Space Program. And in addition, what the science, for example, physics or chemistry or maths, how can we use this type of this science in the real space science and technology? That is the interesting part of this program. It's a very unique program. Every year we are conducting 1 or 2 programs, and this time this is the first program. As I told you, that this is our 9th edition of IIST school. On behalf of all, I express my sincere thanks to the Sargakshetra, also our director and registrar, for accepting this proposal. And I wish all the students fruitful 5 days of IIST school ahead. Thank you very much.
Thank you, sir. Our beloved patron of Sargakshetra, prior of Sacred Heart Monastery, president of this program, Father Sebastian Atichara CMI, is with us. With great pleasure, Father, I invite you for the presidential address.
Pleasant good afternoon to one and all. Distinguished guest of the day, Dr. V.K. Dadwal, Professor Pribula Joseph, Professor Krishnamurthy, and Father Alex Prikram, the Director of Sargakshetra, professors, and dear students. I wish you all the best for the rest of these 5 days. Currently, we are facing so many difficulties. There are so many strain and stress for us. Mental strain is there, physical strain is there. We are forced to wear something which was not accustomed to us, which was not so feasible for us so far. But now we have become quite accustomed to. Now we have become quite adjusted to wearing a mask. It has become part of our life. It has become part of our dress code even. And that's how things change. Change is a symptom of life, signal of life too. Change needs to be there. I'm a literature student, and even now, I love reading. As I read William Wordsworth, he reminds me, the child is the father of man. Number of students can remember it from, where is it from? It's from the poem, The Rainbow. And William Wordsworth reminds us, we are all curious. We are all curious. We shall be curious. We must be curious too. And curiosity comes from, I don't know how many of you can remember or how many of you can recollect. The symbol of education is an unending arch. An unending arch is that's what depicts our process of transforming information, our curiosity that grows. It never ends. Again, Tennyson reminds us, it goes on. The more you know, the more you do not know. That's what is the information, that's what is the knowledge. And now, these 5 days are given to you. I so pleasantly remember the last year's experience. We had a residential program here at Sargakshetra, along with IIST. It was so happy. It was a rich experience for all the students. The valedictory function, even now you can recollect the valedictory function. Students, almost all the students shared their experiences. And therefore, this year also, but the mode is quite different. The modus operandi or the working method is going to be a bit different this year. You are comfortably at your home. We are comfortably at ease, but you are going to be together. There are almost more than 1,500 students taking part in this session. And therefore, I wish you all the best. Make use of it. And that's for the better generation. And whatever be your knowledge, whatever you get from these 5 days, that should be for the betterment of humanity. We work together for the betterment of humanity, science, technology, information, whatever it be. And everything that shall work together, that shall go into the betterment of society. May God bless you. I wish you all the best. Thank you very much.
Thank you, Father. Dr. Vinay Kumar Dadwal is Director, Indian Institute of Space Science and Technology, that is IIST, Trivandrum, and Chairman, Board of Management, IIST, since July 2016. Previously, he has worked in ISRO from 1983 to 2016, including as Distinguished Scientist and Director of NRSC during 2011-16. Other positions held by him include Associate Director, NRSC 2010-11, Dean of IIRS, Dehradun. Concurrently, he was Director in Charge at UN Center for Space Science Technology and Education in Asia and the Pacific as Director in Charge and Head Crop Inventory and Modeling Division, Space Applications Center, Ahmedabad. Currently, he also serves on Board of Governors of APJ Abdul Kalam Technology University, Trivandrum, member Indian Institute of Management Society, Kozhikode, governing body of Indian Institute of Tropical Meteorology, Pune, etc. He is a recipient of many awards, including ISRO Outstanding Achievement Award, Satish Dhawan Award, ISRS, ISRO Merit Certificate for Contributions to Application of Remote Sensing to Crop Forecasting, ISRO ASI Award for Space Applications by Astronautical Society of India, Hari Om Ashram, Dr. Vikram Sarabhai Award for Space Applications by Physical Research Laboratory, Indian National Remote Sensing Award of ISRS, Young Scientist Medal of Indian National Science Academy, and ISCA Young Scientist Award, Indian Science Congress Association, Calcutta. There are 4 more pages of his biodata, and sir, with much pleasure, I invite you for the inaugural lecture. Professor V.K. Dadwal will be doing the inaugural lecture. Thank you, sir.
Good afternoon. Thank you, Marina. Good afternoon, Father, and all my colleagues from IIST. Good afternoon to all young prospective space scientists. This IIST at schools was proposed and encouraged by our first Chancellor, Dr. APJ Kalam, and he wanted that students should be able to spend some time. So we used to get around 200 students, and they used to be there for 2 days plus in IIST. This year, the situation is different. We are passing through a pandemic and a crisis, but learning must not stop. Your careers decisions have to be taken. You have to grow professionally and contribute to the society. We are also, confined to homes and specific places, but still we want to be with each one of you. So it gives me great pleasure not only to formally inaugurate this program, IIST at schools beyond the horizon, but also talk to you on why space should be in the uppermost of your thought. And a quote from Dr. APJ Kalam, he wrote that these dreams or what we want to achieve is not what we see when we are asleep, but these are the things which do not allow us to sleep. So I want you to sleep, but also think about the space. So I would formally just take you through a set of slides. They are quite light, and hopefully you are able to see the first slide. So let us move to what exactly is the critical question all of you have. So what is the profession which you would be joining? I'm sure medicine comes uppermost, engineers, even liberal education for many of you. So I would like to, by the end of this lecture, suggest to you that whichever profession you do, you can still join and contribute to the space. So we all would agree, or I am sure there would be a poll at some stage, that currently humans are in a space age. So space has fascinated humans from very early. They were all participating into this space or space science through observation from the Earth. Then the telescopes were invented and more closer look could be done. There were additional development. Early in the 20th century, the rockets which could leave the Earth and go to space were invented. So with the launch on 4th October of the first satellite by Russians, a space age started. But space age was just not launching a single satellite outside, let us say 100 kilometer, which we legally say beyond 100 kilometer from surface is the space, below is the air. But the space age has slowly crept on us because of the developments in engineering and technology. And what are those additional things? In a couple of years, we could send a human being, then which was the Yuri Gagarin, as all of you know. Then the next stage was we were able to send bigger spacecraft which could see the Earth, photograph it, use it for meteorology. We could launch longer missions which went to other planets and photograph them. We also, within 12 years of the satellite, we were able to land on the moon because of the great focus which was given on manned flight and moon landing by the United States of America. So the new inventions, more engineering continues to be done. At least since 1999, 1998 was the first launch of the International Space Station module. So when it assembled from 99 and early 2000 onward, there is always a human presence outside Earth. Earth is our only home, only abode, but now there are permanently humans staying outside the Earth, not the same set, but a human race is present continuously since 2000, let us say. We all children want to be astronaut. So there is a very substantial number, but still below 300 who have gone to space. But now we are just at the corner where private enterprise, all of you would have heard of Elon Musk and what his company does. Even there would be tourism to space, but it is not that. The US President Obama said during his space vision by 2030, US or NASA would be trying to send humans to Mars and get them back. So the space age has slowly crept on us. More importantly, as I would like to point out later, in our daily life, we are heavily dependent on space. All our regular functions, like the navigation, asking a taxi by an app, Ola, or using the DTH to receive the television programs, or even going to an ATM and trying to withdraw money. We actually use space. Parallelly, the whole universe and the number of stars and the various phenomena and activities which are taking place, the vastness of space is more understood because of the space technology. So my colleagues will be talking to you about astronomy and astrophysics, about sun, about planets. So not only the space is huge, I would like to suggest to you that space requires specialists as well as all others with interest in space, so that space could be a career option. As private industry is becoming more and more involved in space, there would be more and more larger career options for space. So you don't really have to study space. You could study something else. You could study law and do space law. You could study commerce, economics, and still come to space. You could study various disciplines, but from now onward, just think of space and think of how you could contribute to this great human endeavor. So when we think of space, the first thing we think is science. So the space is at the edge and the topmost of science. Astronomy, astrophysics, space exploration, search for exoplanets. It means planets which are moving around other stars. And now almost 6,000 plus exoplanets have been identified. Now the next challenge will be how many of them have atmosphere, how many of them are habitable, and how human beings could reach there. Parallelly, the search for extraterrestrial intelligence, or is there somebody which in the form of literature and movie we call alien, are they there? So that itself is a very, very great scientific and knowledge question which we must answer. So all of those who are interested in science, physics, mathematics, and various other science, including biology, how biological organisms live in space, or science questions as important as how the life originated on Earth. They can be answered or they can be attempted with some inputs from space science and technology. So in first, science and exploration, if whatever be your career, you please learn space. So for new science discoveries, evolution and origin of universe, evolution of solar system, or the origin of life, space can be a very important scientific tool to really address these questions. Let us look as communication. Today, you are participating in this webinar because of the communication technology. So communication technology is required because for interacting with satellites or when we have interplanetary missions, they must communicate with Earth. But communication technology is very useful and is served by space from one point on the Earth to the other. So satellite communication, satellite broadcasting, all these other applications like the space-based education, telemedicine, all of them are helped by the satellite communication technology. The second important aspect of the space is what is called position, navigation, and timing. Now, you could think of human as an explorer as he walked or as he sailed on the seas or as he tried to go to the North Pole or South Pole, or as he was scaling, high mountain, or he was crossing desert. All these things were done before the space age. And for all these activities, there was great difficulty, challenge, and human grit to really complete those tasks. But all of you would be aware, or those of you who have tried to see, now global positioning system place any person precisely on one point in the globe. So he can tell his location or others can reach his location if it is for search and rescue. So the positioning and navigation are very, very important applications of space technology. We already have positioning based navigation for aircraft. Aircrafts are able to land by the such space-based and ground-based technologies precisely, even when they can't see, when the visibility is very poor, or there are other challenges. More importantly, we are now moving into an era of autonomous vehicles in the air, UAS and drones, autonomous cars, and so many autonomous navigation. All this next generation of mobility will rely on space technology or global positioning system. So it has a very simple physical principle. The satellite sends a signal, which is the time. Since we know from the satellite where currently it is, where it is communicating the time. So if we receive more than 3 or more such signals on the Earth, we can do a triangulation and we will know the position. There are some challenges of error in positioning due to the intervening with atmosphere, moisture, ionosphere, or other challenges, which are then solved by various new technologies of very precise positioning, post-processing, or mobile positioning, and other such techniques, so that it is possible to locate anybody within 2 to 3 meters on this vast earth, whether it is land or ocean. Human beings are using earth, rare earth elements and minerals are getting consumed. So would we be able to go out and get resources from outside the earth? Till now, the major resource which comes from outside the earth is the energy of the sun. All other resources we have to use on the earth. But after we have landed on Moon, after we have landed on Mars, the European Space Agency had a spacecraft, mission Rosetta, which actually landed on a comet, Philae lander. Japanese also have a mission, Hayabusa, which is to return samples from comets. So obviously, we will study the asteroids, comets, and other planetary objects. If we are able to go there and land there, at some stage we will be able to come back also and get the resources. Also, if you are able to land and you develop techniques of habitation and the new material processing techniques, I'm sure many of you would have heard of 3D printing. We may be able to process the in situ material on that planet and really create an outpost or really colonize that. This may happen next 30 to 50 years. So the space, so presence and use of space is likely to grow. Now this would be the time domain of all of you, the professional career, which may start another 5 to 7 years and beyond. So in your active professional life, there would be resources, presence, and outposts beyond Earth. I'm sure many of you, one way or the other, would be connected or contributor to such an exercise. So the questions we looked at was, do humans need a home in addition to Earth? Are there habitable planets? How to build a human colony on another planet? How to enhance material resources for humans? How to enhance energy resources? So, as more and more solar power is being used, among the various options is, if we go outside the earth and receive the solar energy there, convert it into energy or electricity, then transmit it as a microwave to the earth. So can we produce electricity outside the earth and then get it to for human use? There are very serious engineering solutions being thought about it. Now, once we understand more about all these celestial objects, and you are all aware that meteoroids land on various places on the earth, can we protect Earth from asteroids and near Earth objects? There are many, doomsayers which say that a big object can fall on the Earth. In the Earth's history, there have been occasions when big space object has fallen. Sometimes it has created a crater. I'm sure many of you would be knowing about Lonar. Also, many years ago, 65 million years ago, there was another large impact which created a winter, a dust envelope around the earth. And many people believe it also led to the disappearance and extinction of dinosaurs. So, even for protecting the humans on the earth, we need to develop technology to protect Earth. First is to predict the trajectory of each asteroid and near Earth object. And if we feel it can harm us, what technology solution we can have to protect the human race. Also, you are from your science and other background, or even from the various article, you would know that sun has sunspots, sun cycle. Lot of high energy particles come. These energy particles, they travel towards Earth. They can have disruption in electricity and many other human activities, communication and others. So to predict such space weather phenomena and also to develop preventive measure, we actually need space technology. So this is just an example produced by the British Planetary Society, where various landings on Mars have happened. So I think, I hope I'm not occluding this. So you can see currently the InSight lander and the proposed February 2021 of the NASA rover Perseverance. And we also, human beings, want to go to Venus. The challenge there is high temperatures. So each planet poses unique challenge of gravity, atmosphere, temperature. So great science and engineering is done for exploring the planets, and at some stage it will be very useful knowledge for human beings. So that brings us to a space station. International Space Station, it was not the first. Skylab and Mir stations were launched earlier. They had limited functionality and limited life. What is so special about International Space Station? It has collaboration between 5 nations: USA, Russia, Japan, Europe, and Canada. It's a 100 meter by 73 meter structure. It has many working quarters. It has sleep quarters. It has scientific equipment. It also has many observation equipment, Earth observation outside. It also has been used to launch CubeSats. So this is a great piece of engineering and technology, although at the moment very costly. That is why so many nations and agencies have contributing to this. There would obviously, as technology improves, there would be newer versions, more capable, which you would see. Many of you can go to the IISS site. Even on YouTube, you can currently know where it is passing through. And in the evenings, if it is passing over your area, you can view it as a sun reflecting object slowly moving. I suggest to all students to learn more about the space station, how they can see the live data, how they can propose photography, which is one way to get involved in the space. Closer to home, the space acts as an eye in the sky to view the Earth. So Earth observation or the remote sensing technology or the use of remote sensing is very, very important for the safety of life, quality of life, even many professions, science, measurement, weather prediction, prevention of disaster. You range a list of activities that are done by the space-based platform, which contain various sensors, which then measure various parameters. There would be a detailed lecture, I think, by Dr. Krishnamurthy, who himself is a remote sensing scientist, of the applications of this technology. But I will just cover some points because they are closer to your home, are very important. So for the life on the earth, you're all aware of the increase in carbon dioxide and the global and climate change. So monitoring climate change, whether it is the land use, whether it is the ocean, or it is the atmospheric chemistry, cloud, El Nino, you name anything. So even the snow cover, the depth of the snow in the poles, sea level, all such things require space observation. Next is forecasting weather. See, weather forecasting, if you just want to do nowcasting, you can just look up, or maybe you can have a radar and do nowcasting. But if you want a 2-day, 5-day, or long-term forecast, which is required by many people, including the farmers, if you want accuracy, then you must measure the ocean, you must measure winds, you must measure the vertical profiles of humidity and temperature. From ground-based sensors, it is not possible to cover this entire Earth. But satellites, especially in the geostationary, they make it possible. So one of the biggest contribution of the space technology has been this great improvement in the weather forecasting of short term, medium term, and then it leading down to better understanding of Earth as a system, monitoring of cyclones or typhoons, predicting their landfall and time, and many such extreme events with use of space technology, their forecasting and nowcasting, and developing disaster risk resilience is very, very important. The other is the sustainable development and protection of environment, whether it is the recession of glaciers, whether it is deforestation, whether it is the depletion of groundwater resources, which can be seen by the gravity missions. So large number of such things can be seen by the satellite data. More importantly, we discussed communication. You can use communication to do simple things like movement of a bird. You know, there are birds who do long range migration. You can use even to do the migration of whales if you put a small transmitter. You can use communication to even know where your ship currently is through various communication and transmitting application. And if a ship or an aircraft requires search and rescue, you can use communication plus navigation to quickly reach and protect also. Now, more importantly, is the location information, which is the GPS or which is also GNSS. So whether it is the aircraft, it is a vehicle asking a taxi, or a farmer who is linking a space photography on crop health with the location of his tractor and doing precision farming. There are thousands of uses of location information. That is why this is very, very important application. So for the quality of life, for safety of life, and for many of the actions, space is very important. Space gives pictures. Pictures have huge information. It allows us to understand phenomena. It allows us to make measurements. You can do analysis and visualization. All of them are of great help. I will not have detailed space application, but just a couple of pictures so that your excitement can be built up for the space technology. So these are two very iconic pictures. The picture on the left, we are all familiar with moon rising, but from the moon, you can see the earth rising. So this led to the earth being called blue marble. This picture was taken from Apollo mission of NASA. And you can see the huge cloud and the vast area covered by the oceans. Same way, when going towards Mars, a NASA mission looked back and captured both Earth and Moon together. From this picture, you can see on which side the sun is, the sunlit side and the dark side. So this picture has very, very large number of interpretation and observation issues. There is one of the lecture by my colleague, Dr. Rajesh, who will talk about what these pictures of the planets tell us about the origin, processes, and various activities on the planetary surface. So the eye in the sky covers large areas. You can cover the same point multiple times. Human eye looks in a very small part of electromagnetic spectrum. The satellites allow us to look beyond this, beyond the human eye observation, including by microwave, which can penetrate through cloud. You can have various spatial, spectral, radiometric resolution. You can measure geophysical things like temperature, ranging, forest height by lidar, gases, chemical species in the atmosphere, large number of geophysical parameters can be done. Since a picture is available, so you can do a historical analysis, plus you can study areas where humans have not reached or humans have not yet established some instrumentation. So the Earth observation is a very powerful technique. And it is not one technique, it is a range of technique of multiple band, hyperspectral band, use of microwave to get the surface and dielectric properties, use of lidar, like the atmospheric lidar, to measure the particles in the atmosphere, dust, cloud, and other particles, use a surface lidar to measure the height of each building and tree, use thermal emissions, use altimetry to measure the sea surface height, look through the atmosphere to the sun to get the chemical species, use microwave ranging to measure the gravity, which can even help us in seeing the groundwater depletion or flood or the tides or increase in the snow. You can measure the output of the sun, irradiance photometry outside the earth, and you can do the altimetry and scatterometry to know the surface of the ocean, and the roughness of the surface of the ocean can actually help you know the near surface winds. So you can really measure the winds over the globe by the scatterometer in addition to a large number of applications. So why I wanted to show this slide was to tell that the remote sensing technology is huge, has innumerable properties and applications. And now there are private companies like Planet, which have small CubeSats, 200 plus. They can cover any part of the globe every day. And they collect almost 14 million pictures per day. So these pictures were not high resolution. So let us look at the high resolution. This is a Taj Mahal, which you will recognize, taken by World View. And you will also see the power of shadows. There are people who are standing on the marble, and because of the shadow, you can see, perhaps count how many people were visiting when this picture was taken. So as we are passing through this COVID, and the satellite pictures have mapped the parking lot of various shopping malls which are just vacant, which is an indication of no activity. So the pictures allow a host of interpretation. This is a very important picture which was taken on February 11 by Digital Globe. This high resolution picture actually shows the size of the crowd in in Egypt, in the Tahrir Square, which led to toppling of the government. So this is the power of imaging. I'll show you a 25 centimeter picture, World View 4 over Tokyo. You can see the type of objects, and it also leads to many type of analysis, which we will not worry at the moment. But you can see the roads, the cars, the marking, the stadium, the type of rooftops, the structures on the rooftops, even the trees with different colors. Now, more and more such pictures are being used in humanitarian crisis. So this is the border of Syria and Jordan. You can see large number of refugees, tents, people on this side of the border waiting to go to the other side. So the space photography has become a tool for transparency, for efficiency, for governance, and global sharing for various applications. This is nearer our home. This is the Deonar dumping ground in Mumbai. So a couple of years ago, when somebody put fire to this landfill site, even the schools had to be shut down. Nobody could move. Such intense was the smoke. This is picture of Antarctica, where a huge ice shelf broke between January and first fortnight of February. You can see a sequence of images. So the red line shows the earlier. You can see how various icebergs have broken and are floating. And the third picture and the fourth picture, you can see such a huge area, 2,600 kilometers and thousands of icebergs. Such phenomena will become larger as oceans heat, sea level rises, and climate changes. They have very strong influence on navigation and sea level rise. So satellites are a very, very important to monitor such things. This is a daily monitoring of forest fire in India. Each red dot is a fire. So every day, multiple satellite pictures, you measure the forest fire, and you can see in March 11,000 fires, and daily the location and number is getting counted. This is a bit old. The very significant part is that 95% of the forest fires in India are man-made. So we need to prevent such fires, and whenever there is a fire, we need to take action so that it doesn't spread, and very economically important resource, forests are not burned. So this is the power, because you can't be everywhere to measure. Same way, I would like to say, I already pointed out, space is very important for farmer, for rainfall prediction, for precision farming. It is also very important for fishermen. He can reach the fishing school. So in India, there is a potential fishing zone forecast PFZ by IIST every day. So the fishermen know which direction and what distance and what sea level depth they should reach where more fish are present. It saves them time, it saves effort, and their livelihood is improved. So space is also, as I said, very important for travelers and explorers because of the GPS. All such things are there, but there are some challenges and danger. One of them is the space weaponization. Earlier, the emphasis was demilitarization, but now the militaries use space for communication. They use space for the GPS. But the danger which has come is the anti-satellite, ASAT type of things, and more are being done. As more and more satellites get launched, the space debris is increasing, especially the bigger one. There are possibility of other mishaps in space also. So there are very large number of debris around the Earth, and also there is a debris in the geostationary orbit. So Earth is the first planet which has artificially created this belt of such object. And as you are already aware, ASATs have been tested by United States of America, Russia, and China. And this year, India tested and became the 4th country by neutralizing a defunct satellite at 300 kilometers. Low altitude means all debris should fall down much quickly than compared to the earlier test, some of which is still there. So space requires new paradigms. Space is very costly, so it requires international cooperation. Now you are going beyond your airspace and your boundary, so it requires new laws, new treaties, and new governance models. Up to now, most of the space money was spent by government, but then government channelize it in specific direction, and it always may not be the best way to use it. Governments are a bit slow in rapidly changing their priorities. But what now space needs is human entrepreneurship and private enterprise involvement. Many of you who are reading the newspaper would be knowing that even the government of India has identified opening of space to private players in India. You would have also become aware of the Elon Musk and how his company has brought back the rocket used part to land and reuse, how he has also delivered the first private cargo to the International Space Station. So while all this happens, new laws and policy and regulation would be required at national level. So the space is, as I mentioned, for the entire society. Even if many of you do not directly become an engineer, space scientist, or an astronaut, please know more about space. Please participate as an intelligent participant to this great enterprise of space. At this stage, I would like to end my lecture, and if there are some questions, it is very difficult to interact with such a large thing. So what I suggest is you could in chat send your questions to the coordinators. So coordinators can then group questions into common topics, and separate answers can be mailed to you or can be put on the Sargakshetra website for you to read. Thank you very much. It was a pleasure and it was a privilege to address such a large bunch of enthusiastic space enthusiasts. I'm sure you would be having great career, and you would also perhaps help us, India and humans, do more in space. Thank you once again.
Thank you,
Thank you, sir.
Dr.
Thank you, sir.
Vicky Dadwal, sir. Thank you very much. Your inaugural lecture has enabled students to understand the basis of space science. They have also got the gist of what they're going to experience in the next 4 days. Moreover, I'm certain you have made them all to take the responsibility of protecting our Earth and mankind. Thank you very much, sir. Next.
Thank you, sir.
Yes, sir. Next, we have Dr. Y.V.N. Krishnamurthy, sir, served as Distinguished Scientist in ISRO and currently working as Senior Professor and Registrar of Indian Institute of Space Science and Technology, Thiruvananthapuram. He is the former Director of NRSC and Secretary of ISRO. Presently, he is facilitating in building payloads, sensors, small satellite space-related systems, and for Gagnan. Besides teaching and research, overall administration, expanding the infrastructure and facilities to meet future demands of ISRO and industry. Chairman, Research Advisory Council of NCCR, Ministry of Earth Science. Dr. Krishnamurthy has significantly contributed during the last 4 decades in promoting remote sensing and allied geospatial technologies in resource management and extending their use at grassroots level. His contribution in developing innovative methodologies by integrating geospatial inputs into conventional methods has greatly facilitated in ultimate assimilation of such inputs in the planning and implementation of developmental programs by the concerned. He has played innumerable pivotal roles in all areas he has headed, and there are lots of awards conferred on him. Indira Gandhi Gold Medal Award, Excellence Award from Union Geographical Information Technology, Lifetime Achievement Award from Deccan Geographers, Bhaskar Award, ISRS, Team Excellence Award, ISRO Performance Excellent Award, and lot more. He has about 208 technical papers and 280 technical reports to his credit. Dr. Krishnamurthy has guided 8 PhD scholars and developmental of 25 indigenous software packages, organized more than 500 training programs benefiting international, national, state, and local participants. Here, sir, I invite you for felicitating this gathering. Thank you, sir.
Yeah, thank you. But I understand I had to give a presentation too. You want the felicitation now and close this session, Sajumon? And then we start again?
Yeah, sir. What you can do is you can say a few words and you can start your
fine.
talk.
Yeah. First of all, I would like to thank the our IIST, my colleague Sajimon and Dr. Kuruvilla Joseph, and also from Sargakshetra, Dr. Father Alex and Father Sebastian, to give us this opportunity. And this time, because of the pandemic, we are not just in the premises of your institute and your people, but also entire country is covered today with people following it up. That is one advantage of going online and then having this webinar session. And there's an important talks, because I see in the chat, some of the colleagues are looking for fundamental physics. They would like to learn. And I was just browsing through the some of the chats which are going on certain applications. So you'll find the teachers who have been, or the professors who have been selected by my colleague, Professor Kuruvilla, are actually very interesting teachers. They make the lectures very interesting. And you heard now the director of IIST to give a flair of what space and how what are the uses of it, and how daily we are using many things without our knowledge. And today that has become part and parcel of our life. And more importantly, we all have to look in. The government has, from this pandemic, and then we have so many other things happening, and the geopolitical situations are changing. Then we have to have our own indigenous technologies everywhere. And also the government has launched Atmanirbharta. So, and then that is startup and stand-up was there previously, that you have to be your own entrepreneurship. You're all from 10th to 12th standard students, and space is has a lot of opportunities, not just making satellites, launch vehicles, etc. But then it also has indigenous sensors which you can make, and what you qualify for space are very useful for common use in our day-to-day life, because for space you need a higher qualification. So, but then for daily use, you don't need that kind of a precision in terms of the quality in the life. But then at a low cost, we can have such devices, and that is one of the greatest opportunities you have. So across the country, young boys and girls, this is an opportunity for you. Maybe I'll be speaking to you after this session is over, but I'll focus more on the applications which the government investments are going on. So now we all think that there are quite interesting things happening. Space is very exciting, but also you should understand how much money we have within, and because we are still a developing country, we have still 1/3 of the population doesn't have properly 3 meals a day. So as a citizen of this country, you all have a responsibility how to take care of such while we are developing. That's the most important part. If they are not taken care, or what are the priorities given when the pandemic has come? Why we have given more importance to the migratory population? Why the preference has been given to the farmers? And Prime Minister in his address also, he only told thanks and namaste to two people. One is the farmers and the taxpayers. These are two important things. So unless you have a finance, you don't have money or economy, good economy, you cannot really greatly explore into space, because space is an expensive business. And you don't have that kind of a numbers where you can make a commercial applications. So what we all have to focus is on where you can make your fascination for science or your ideas for exploration of science. What is your contribution which you can give back to the society, in which you don't have to be free. It gives you an investment back to you. So you take some returns, but also enjoy this subject. So there's a wide variety of diversity of things are available as far as space is concerned. And you will hear right from exploration, and I'll deal more about the applications, the government requirements, and what is happening in the country with few examples. And once again, I thank Dr. Kuruvilla and Dr. Sajimon, and then especially from Sargakshetra, the pattern and the director taking keen interest, and Marcena, CB nicely conducting this program. Marina conducting this program. Great. Wish all the best to all of you, and I hope this will give you a new insight in the future days to come. All the best.
Thank you very much, sir. Students, you will be able to meet YVN Krishnamurthy sir again. This was just a short felicitation from him. In the upcoming days, you can meet him more of him. Thank you very much, sir. Now we have Dr. Shaijimon CS, Assistant Professor of IIST, and he is also a team member of Sargakshetra. In fact, Sir has organized this beautiful platform for you all students through Sargakshetra. So let me take this opportunity to thank you, Sir, as well as I'm requesting you to propose the vote of thanks for this inaugural ceremony. Sir, please.
Thank you, Marina. Respected Director IIST, Professor V.K. Dadwal sir, respected our Registrar, Professor Y.V.N. Krishnamurthy, dear Dean Academics, Professor Kurivula Joseph, Father Alex Parikalam, CMI Director, Sargakshetra, Father Sebastian Attichira, CMI Patron, Sargakshetra, my dear colleagues, my dear students from all over the country, and I was told that from other countries as well. It's indeed a proud and overwhelming time that we had right now, because the kind of response that we got from all over the country regarding this program. And this is 9th edition of IIST Schools program organizing by IIST, 2nd edition along with the Sargakshetra. And the primary aim of the program is to instill the scientific temper and scientific attitude among the school children by presenting them before the different areas of space, science, and technology. Through space, science, and technology applications and research and the different areas of space, science, and technology, we wanted, IIST always wanted from its inception onwards to create more scientific spirit among the children, among the school students of the country. So in that direction, we have very much succeeded in the different versions that we organize. Usually, as Director rightly pointed out, we invite the school children to IIST or some other common place, and we have this in-house 3-day program with different subjects. This time also, we are getting almost students from almost all the states of the country. And then, this is, as Registrar rightly pointed out, this is an opportunity that, more people can join this program, because when we organize it in-house, only limited number of students can join the program. So I am very, very thankful to first of all, I'm very thankful to our beloved director, because right away when our dean discussed about this program, he always in the forefront of organizing such programs for the community as well as society and for students, particularly for school students. And I thank him profusely for making this program wonderful, and especially thank his wonderful inaugural lecture also. Thank you, sir. Next, I would like to thank our beloved registrar, Y.V.N. Krishnamurthy sir. Always after he joined in IIST, he is in the forefront of organizing such kind of programs, motivating the students. And you can listen the next after me that he is going to give a lecture on the applications of space, science, and technology. Thank you, sir, for being there, for all the support that you extended for organizing this program as registrar, as well as the faculty member of IIST. And now let me thank Father Sebastian Attichira, CMI patron, Sargakshetra. He has delivered a wonderful lecture related to the objectives of the program, and during this pandemic, what kind of attitude that we should have. Thank you, Father, for such a wonderful speech. And I must thank Professor Guruvula Joseph, the Dean Student Activities of IIST, his friend, colleague, professor, everything, and he is in the forefront of organizing such a wonderful program. So he is always instilling confidence, and thank you for giving me the opportunity as coordinator for this program also. Thank you, sir, for that wonderful wonderful speech also. Next, I must thank Father Alex Parikalam, CMI director, who is so wonderful. And every time actually he is calling me, and then I'm calling him, and then he's so open. And whatever problems that we say about organizing this program, he has instantaneous solution then and there itself. And then he just have all kinds of positive attitude and all. I'm sure that you all the students can actually see that how professionally they are going to organize this program for the next 5 days with us. And I thank him for that wonderful support provided. I thank all these coordinators, including the anchor Marina and all the people that are associating with this program. I thank on behalf of IIST, I thank you all for this program. Thank you very much. Have a nice, and I expect that you will all have a very wonderful, nice, informative program for the next 5 days. Only one request I have is actually please seriously attend the program and listen carefully. You're going to listen the wonderful stalwarts in this area. Like you will not get such an opportunity from any other place. I'm very, very sure that every time we get the feedback when we organize such an opportunity, when we give such an opportunity for the students, please listen carefully and then study well. A lot of informations are going to come. Thank you all. Thank you very much.
Thank you very much, sir. Students, with this, we have come to an end of just the inaugural ceremony. Soon, we will be following by a special lecture by our registrar, IIST, at 3 p.m. Maybe a small 2 minutes break you can take if you feel you need a break, but at 3 p.m. sharp, sir will start his special lecture. And at 4:15 p.m., you will have a theme lecture by the Dean Students Activities. So just we all are waiting to hear you all, sir. Thank you very much for this wonderful session to all of you. You can take a 2 minutes break and we'll be joining exactly sharp at 3 p.m.
Hello. I think we can start. Marina, you are there? Marina? Hello. Marina, can you hear me? Hello? Hello?
Welcome back,
Yeah.
students. I'm certain you all are ready. We are here with Dr. Y.V.N. Krishnamurthy, sir. Sir is ready with a special lecturer for students. As I had introduced before, he is the registrar of IIST. Sir, we all are waiting to listen to you, sir.
Thank you, Marina. And allow me to share the screen. So I'll get
Yes.
into a few slides, which
Thank
will be
you, sir.
interesting.
Yes, sir.
And
Yes,
my
sir.
slides I'll forward as a PDF to you, which can be shared with the participants because they can go through and have certain questions or what is that they can explore.
That
they
would
can
be
also look forward in the
wonderful.
future.
Students were asking some doubts. Probably these slides will help them. Thank you, sir. We will
Marina, allow Professor Y.V.N. Krishnamurthy sir to share the slide.
Yes.
Slides, yeah, please go.
Acha.
Yes, sir, it is visible.
Yeah.
If we can put it on the full screen, sir, if we can show you the full screen.
Yep.
Yeah, good, sir. Very good.
Yes, sir. Thank you. Once again, thanks to outstanding Professor Kurvilla and Saijimon and Father Sebastian and Father Alex, and also dear students who have joined from different parts of the country and maybe outside the country too. And I selected this topic on geospatial technologies because space and space inputs becomes part of geospatial technologies. And then what is for the national development? Because the first question anyone asks us is on what is it for the national development? Any technology. It can be exploration, but then before exploration, how it is useful for the common people. I was also mentioning a few minutes back how we need to understand the requirements of the people who doesn't have work, people who doesn't have home, people who doesn't have the minimum requirements of shelter, how things can happen and whether space can provide such with various ministries. For example, you can look into various satellites which are mentioned here. There are for all thematic satellites called land and water, high resolution satellites, and not all satellites are imaging satellites. There are certain sounders, there are scatterometers and radiometers. So there are a lot of non-imaging satellites also, which give you the information. And these are a set of names which has been given. So I'm not reading out the names. This is to give you a gist of type of satellites which are there. One, what is HRSAT is high resolution, hyperspectral remote sensing and high resolution satellites. GISAT is a satellite for imaging from a geostationary orbit. That means from 36,000 kilometers, it's going to image. Whereas all other remote sensing satellites normally are in the low Earth orbiting. So they are something from 400 to 800 kilometers from the Earth. They image and give us different resolutions. And based on what is that resolutions and how it looks like, we will get into the next slides and then see. And now we also have communication satellites because these are also very important. Today, we don't talk about Earth observation satellites independently. We need these communication satellites too, and also the navigation satellites constellation which Dr. Dadwal has mentioned. We have a constellation called NAVIC. With 7 satellites, we are able to get to our country, and also 1,500 kilometers from our boundary. We can transmit the signals and get the navigation information. So these are for societal applications like tele-education, telemedicine, and also our direct bank transfers. Suppose if you look at Arunachal Pradesh, you have villages today called 5 day by foot, 3 day by foot. That means you can see the village, but to walk and go there, it takes a time. So for that, the communication links are all through satellite based, and also the direct bank transfer for the individuals who are below poverty line, or for who are doing work for the work which is being given under Rural Employment Guarantee Scheme and such things. And also mobile satellite services, telephonic carrier, multimedia delivery, and VSAT services. So there is so much, including our stock exchange. Everything is dependent upon the satellite, communication satellites. So we have series of satellites called INSAT and GSAT satellites for such applications. You also have to know, it is not that there are wonders done by the people who are developed countries. India is the first country in 1995 to launch a satellite called IRS-1C. This has what is called 3-tier imaging, because you should understand the country, our India is very huge, and we need to cover the entire country's resources, and not in detail at every time. So here you can see there are 3 cameras operating from the same satellite called, that time it was IRS-1C, and after that we had 1D, now we have graduated, we have ResourceSat, now we have ResourceSat 2 series. So these 2 series has a wide field sensor. It covers a large area. You can see 740 kilometers. What does it mean? I'll show you an image. And another one called on 141 kilometers. Another one covers a smaller area in greater detail. That's around 70 kilometers, which is other detail. So this is the first time India in 1995 gave to the world the high resolution satellite data. That time only a French satellite data with 10 centimeters is available for civilian use. For defense use, people may be having very high resolution. But India is the first country in 1995 to give 5.6 meter resolution for the entire globe. So the people across the globe could access this data and have for their varied applications. And you can see here, when I talk about AWIFs, it covers such a large area, almost like 800 by 800 kilometers. That means entire one state can be covered on one shot, and this you can get every 5th day data. And here it is 141 by 141 kilometers, a smaller shot, which can look at a few districts. But then here, a smaller one, 70 by 70 kilometers, will look at a particular block. So these are all like administrative units in any area, because we are a federal government and we have a states, and states control the land, and all the applications has to be handled by the states. But there are certain national applications which is looked at. Now, the other resolutions part, what Dr. Dadwal has mentioned, there is one spatial resolution. Just to get a view for you, for example, you can see on the top left corner. This is at a particular resolution in 56 meter resolution. This is in 23 meter resolution. But you cannot find any difference between these two, except this is a little blurred. But or else all the black dots, the lines, the redness is the vegetation here. These are the water bodies. These are the roads. Everything is clear here. That means if we sharpen this image using digital filters, we can get the same achievement. So that is where the future satellites, when I talk about GISAT, a geostationary satellite imaging from a geostationary orbit, is going to give an image of this nature, but you can get the details at the 23 meter resolution. So always never get caught in these resolutions. Okay, there's a satellites, because of there's another resolution called radiometry, which gives you better than what it is. That means the satellite detect much more than what we can recognize. So whatever the satellites are detected, how to bring into a recognized form. So there's a lot of image processing techniques in which there's ample opportunities for youngsters like you. This is what I was telling you, at 23 meter resolution, you get little more details of the same terrain, but for a smaller area. That means if you are continually looking at a finer information, at times if you don't have finer information because of clouds like this, even with a coarser information, we can do processing to look at the finer and conclude. Because when certain applications which I tell you, which needs a continuous data for such areas. Then also we had a satellite called Cartosat-1. This is a stereo imaging satellite. That means it can develop the 3D views. To give an example, if someone is from Karnataka or from Bangalore, there's a query when you are going towards the airport. So you can see the difference between the digital elevation model from 2006 to 2009, but how much volume has been excavated from that, it gives you the information here. And this is from 2006 to 2015. That means how much tons, that means how much trucks have moved, whether that much of royalty has been paid for whoever has taken it on lease. Everything can be quantified, and we can look back into such scenarios. This is from the same satellite. You can see the building heights and the heights which are given here. And also this is the World Trade Center, Bangalore, how the buildings have come, what are the building heights of it, everything measured from a satellite with 2.5 meters resolution. Please understand this. So it is not the resolution which matters, it is the application which matters. And there are very important image processing techniques. We can bring in much greater differences and in the heights, which is for our day-to-day applications. This is where our Cartosat series of satellites, this is 50 centimeters resolution. Please see in this stadium, you have certain steel ropes which ties here. But not only the steel, but also the shadow you can see. That is the greatness of, that means you have a steel wire which holds a base, which shadow you can see here. Even the other part also is visible. These are made in India. These are already indigenous satellites. And also you can see the tennis court, the lines. The line may not be width, may not be 50 centimeters, but you're able to detect that. That means the satellites of a particular resolution detect much more than the resolving power what it has because of radiometric resolution, which is very good from our satellites. That is where, and then with image processing, you can make wonderful outputs, whatever is needed. Here you can see a bridge being constructed and something is on the way. You can see the cranes and the shadow of the crane. So what is the height of this crane arm? You can measure. This is the shadow of it. And these small agriculture practices, because in India we have small land holdings, and each of the land holdings, different crops will be there. Some are organized structures, somewhere the bunds are not properly organized. So many things will happen. And there is a bund of a tank, and you can see the water body, which is not full here. And certain people are taking some sand or a mud or quarrying temporarily in those areas. Then you can see this is part of Egypt, because all our satellites are global satellites. That means they cover entire globe. See here the Cartosat series of satellites we had, so up to F. And then you can see the pivotal and also the crop which is growing. That means our satellites not only look at what is happening in our country, but across the country. That means you learn a new technique here, you can become a global figure. You can do elsewhere also, go elsewhere, use our satellite data to do the applications which I'm going to show you. So this is where, and then now the puddling has been done, or where the crop and crop status, where is the greenness is good, where the greenness is not good. So how to do certain measures here is what we can look for. And this is also again from the same satellite, Dubai and environments, because you can see very high-rise buildings and how the different boats, everything has been put. And we can go into more greater detail to give a bigger view, have compressed this, and then kept this image for you. And this is our Cartosat series of satellites also have what is called an EVM. That means when the satellite is moving, the camera is looking back at the same location. That means the Earth is moving east-west, the satellite is coming down from north to south, but then that is called descending orbit. But then the camera is looking at the same, at the back. So you are getting a lapse. In that lapse, we are able to get a parallax, and you can get digital elevation models. So this is part of Raipur city, the buildings and the river, all has been generated through such cameras. So this is called very specific camera. That means you can get a video stream. You get a continuous. That means if a long building is there, you can get the two sides of the building, and you can generate such building heights, or what is the depth of the pond. That means the profile of it, or there's a river. What is the profile is the river. Each color tells the height variations which are coming in. Then also you can see these are used for, these are basically LiDAR based, means you can also use LiDARs based, that is laser based, to get finer depths. Such depths has been done across the coast of India. so that if a tsunami comes or else then storm surges come, what will be the area which will be inundated? That becomes very clear out of it, and you can also make topographical maps, 3D views, etc. And then this is what it shows of how the flood, this is in part of Tamil Nadu, there's a 1 meter, how much area will be covered with water, and 2 meters, how much it will be there, 3 meter, how much it will be there, and 4 meter, how much it will be there. I hope you are able to see the simulation which I tried to show you. So this is where we need to plan, if so and so, how many number of people has to be evacuated for certain purposes. So we can also make terrestrial building heights. You can make with your own handheld. This is based on LiDAR. Whatever you're seeing applications here of these buildings which are there. There's a forest research institute in Dehradun, which is a very symmetrical and perfectly planned building. But you don't have to do that. You can do it with your mobile phone too. Low cost alternative. That means whatever the mechanism which you have in your hand, kindly see this. This is done with a mobile. If you have 2 overlapping photographs of a given area with 60%, you can generate. There's a software called Tribum. You can go to IIRS in Dehradun website, and you can download this Tribum on your machine, on your computer, take overlapping photographs, and then feed it to it and tell which mobile you have used. So we know what is the focal length of the camera which has been used there, and automatically it makes it. And then you can morph what is the photograph which has you are taken in the field. On the digital elevation model, you can morph. Backside, you can see the satellite data. On the building block, you can keep these buildings. What is important here is you can also look at what is the population which is there. Suppose this area gets flooded, how many people has to be evacuated from here? Which is the building? What is its location? And here the navigation is used. So we know exactly the location of the building and to reach people for rescuing, or how many people to rescue, to plan in a control room. That's all possible. And out of your fun, if you want to make some models, you can do by it yourself. Another most application is because the government or for yourself, when you had to do something, you own a land, but the land has a number. This is called survey number, or sometimes it's called parcel number. You can see these are all, each parcel has a number. I didn't put the numbers here because it becomes clumsy, but then all this is a government land. These are small landholders, and we have a number. Based on this number, we know which farmer is a small farmer, marginal farmer, or a large farmer. The government has schemes, different schemes for the small and marginal farmers, in which how much subsidy they can give, 60% subsidy, 80% subsidy for a given scheme, which they want to implement. So to identify, this has become a game changer. Previously, these cadastral maps had no coordinates, but then we used a mechanism. You all have, if you are already completed 12th, you must have read your polynomial equations. So this is second order and third order polynomial fit has been made for on the cadastral maps, which doesn't have coordinates, but we've given control points on the satellite, a location of a particular tank location or a field bund, which is very conspicuous. Such points have been given, and these maps have been transformed, and now each location has a geographic coordinate like latitude, longitude, and it has an applications varied. So ISRO itself has done for 8 to 10 districts, and some of the states like Chhattisgarh, Maharashtra have did with their own investments, and other states are following under Land Resources Modernization Program, Land Records Modernization Program of Government of India. And then the applications, broadly, Dr. Dadwal has mentioned, that means we do in-season multiple forecasts. That means 1 month before the crop is harvested, 8 to 11 crops today, we give the figures of how much is the produce which is going to come to the market, and anything which is going to change in terms of market economies. That is what is, this is one of the major applications, and most of our satellite images, multispectral, are tuned towards agricultural applications. And inventory and mapping, I will show you some areas. That means this, how the canal systems are properly maintained and how they are being utilized and how much crop is coming in each of the crops. Similarly, the watershed management in terms of productivity. Why watershed management is because for a country like India, we have a high rainfall, and then there are areas where the land is getting degraded. So we need to know any interventions done in terms of water harvesting, how it is going to impact. So watershed is a small unit of 5 to 10,000 hectares. And what are the implications in terms of incoming solar radiation and the runoff which comes in? And when you make certain structures like gully plugging, that's all called water and soil conservation techniques, how much water moisture you are able to retain, so that how much agricultural practices you can enhance. And government is investing here today almost like 1,500 rupees per hectare. Please understand, 1,500 per hectare in the country is being invested to conserve the soil and the water in small pockets of the lands across the country. And this is where the potential fisheries zone, we have a series of satellite called OceanSat. This gives the ocean color. Based on the ocean color, we know where is the diatoms and phytoplankton which is floating. On top of it, there is a set of fish. And also we use the sea surface temperature, because there's a conducive environment, plus the food which is available from which we can know from the ocean color. The third is wind vectors. That's where I was telling you scatterometer. The scatterometer gives you the wind vector. So how these blooms will move with time. So it is not a static thing. On the oceans, things are dynamic. How we give this information. When the search time is reduced and the fuel cost also reduced, there's a survey done which shows 35,000 crores per annum, per year, is the savings based on this forecast of potential fishing zones. So now we are going to launch OceanSat 3. And 3 is not 1, but 3 and 3A. That means we have a series. And each of the satellites has lifetime of more than 5 years. So this is and as I told you, these all satellites are global. Whatever you learn in India, today these kind of potential techniques are needed for across the globe. So you can become an entrepreneur, understand the basics, physics of it, how it does, what when we go onto the sea, we cannot see these diatoms and this thing because of Rayleigh scattering. But from a satellite placed somewhere around 500 kilometers above the Earth is able to do it, because we are able to keep certain bands in which we can recognize the hindrances, why we are unable to detect such, and measure accurately the water leaving radiance, and that makes us possible to get this potential fishing zones forecast. And this regularly is given by IIST in Hyderabad. And also snow and glaciers and forestry. This is done by the Forest Survey of India. They make an assessment of the forest cover in every year, every 2 years. And there's an NR census is done by ISRO, that is on land use, soils, geomorphology, the land degradation, snow and glaciers, and vegetation. This all information is available on Bowen. I request you all on Bowen, you can get all this information where you can go for your own analysis if you want to plan in future. On this urban, I will come back a little later. The weather and climate, as I mentioned to you, there are quite an amount of information which has been brought out. There's in NRSC, there's a website on IIST, on Bowen also you can see. All these are available. There are what is called essential climate variables. There are some 51 essential climate variables. Out of that, 23 are amicable through space. And these are very important measurement mechanism to understand the climate change. So from space, whatever is there from 23, 13 is already we are measuring and we are putting in the public domain. These are all climate qualified data sets. That's what it's called. And this anyway, Panchayat level, I will come to you. And this is where the hot weather. See, these are the predictions which has been given. One of the important aspects is this comes and then predictions are given. The district collectors have been informed, but still youngsters are dying in some of these places where you had the sunstroke, due to sunstroke. So what we did is, in one of the states in Telangana, the doctors were asked to give a communication through the cable operators. From the satellite communication transponders, that information has been transferred to the cable operators. To every home, it has been transmitted, but by doctors giving the information about what is this weather forecast in terms of hot weather and what it implies and what precautions to be taken. So in 2016, in that state of Telangana, there's not even a single death. So this is where what means any application you have to take to the end. Then understanding the science, convert into a technology tools and making it into an application, and how this application reaches to the people. So everywhere there is a set of things to be done. And for doing that, you have an opportunity as an entrepreneurship. And then here, there are other ones called ease of doing business or the governance, which we are telling. So if you have heard in the news, there is a funding which has been enhanced for rural employment guarantee scheme, because under this pandemic, most of the small and marginal farmers or the landless laborer will not have work. So what is the work efficiency which they can do during this period? So the amount has been increased. Now it has a project of 1 lakh crore, one of the biggest investments government has made for livelihood security. So that's an opportunity. But here, what is the importance is, if you see this map here in India, every location, what work is being done, who is doing this work, what will be the result of this work, all are measured. Because there's a convergence of projects. As I told you, this water conservation and soil conservation, they converge into this area. Now we get an information. If you go into Bhuvan, go into this Geo Manrega, and then click in your village, how much works are being done, who is doing this work, and what are the benefits he is getting, or the area is getting. You can get this information, so everything is transparent. Because there's a transparency, that means there's a good governance. Government could take a decision in one stroke to enhance from 40,000 crores to 1 lakh crore. That means 60,000 crores. But to analyze and tell what activities are done, there's not much of infrastructure. So to analyze this, even anyone can access through their internet and do the process and provide to the government such evaluation mechanisms. Maybe some things you will hear from Saji Mohan in his academics of the space technology. Similarly, the housing, stages of construction, which is being done in different states. These watersheds which I have mentioned, there are 2 apps called Srishti and Drishti, which looks at the implementation and impact of the developmental activities. That means what an action is intended to give a result and what this result has really come out. These are the 2 things which comes in. These I will tell you in another one. But ease of doing business. Suppose if there is a heritage point, that means you have a fort or a palace or a very ancient thing which need to be preserved. So around that, if you need construction, permission to give it used to take a lot of time. Today it is only you downloaded that app and then click the location on your own mobile and then send it to the for an NOC, and then within 72 hours you will get an NOC. Whether it is yes, if you want to raise the building height or you want to construct a new building, and if no, why it is not being done. And this has been projected as one of the ease of doing business, while our own country, how it is making the business for people to put through. This is one of the applications. Based on that, we have many applications which has come. So it's also the postal services, health, law and justice. So there are so many areas which these applications are working together. I want you to draw your attention to this particular image where you can see certain lines. These are the lines, okay? These are all what is called fractures. So the water is not just moving along the drainage line, but also it moves across. See this line? It is going across the divide. That means always we think the water is flowing along a river system, but that is not so. But these fractures in different rock systems, these are all crystalline rocks, it is cutting across the drainage divides. That means these fractures take a lot of fresh water even into the sea. We normally think from the estuaries, the rivers take the fresh water into the sea, but it is not so. Besides that, we also have these fractures which drain fresh water. That's where you get shrimp deep in the ocean. These can be up to 2 kilometers away from the coast. These can be 100 kilometers away the coast, and then in such areas which you can put through. But you also have dikes. Sometimes when you get a good water here, you may not get a fresh water here because these dikes make an obstruction for this. And this height of image at a coarser resolution, you can get all these small joints, everything very clearly. But when you go to very closer, very fine resolution, this gets diffused. So that's where there's always advantage. You go more closer, sometimes you miss something. So you have to look from a distance, a comprehensive view, and then come to closer to make that applications possible. So this is the fracture zone which is there, but it is diffused here. So it is not possible for us to find out. And then this is a small tank and the moisture is moving from here to other tank, and this is the dike. So if you get one side a good water, the other side you may not get if you drill a bore, you may not get good fresh water there. Water can fade. It can be a few meters from one location to another. But these can be very precisely understood. And also you should understand that if you do this, if you know the dip and depth, there's a geophysical survey called for geoelectrical resistivity survey, where you can understand the depth and dip. That means in which direction we know from this satellite image, but then you also can know in what angle it is. So at what depth it is going to open into the ocean, or what is going to open. Suppose you don't want the water to go away. Suppose you are in a small island. You don't want the fresh water to go away. You want to stock that water than the fresh water. Suppose if you have Andaman Nicobar Islands, they're small islands, you need to make a water source. If the rain comes, you can fill in some water. But so you can do some clay grouting, because these are all highly weathered zones. In this weathered zone, you can do some clay grouting. So the water at the back end will be always available to you as a fresh water, as a reservoir underneath. And this is what I was telling you about the irrigation potential. So you can see on different dates how the irrigation potential has been estimated. So this is still a supply-based irrigation system. There is a demand-based irrigation system from the satellites, because as I told you, every 5th day, every day also you're going to get the information. So we can know for each crop, what is the crop water requirement. So exactly that requirement for that crop, if you are able to give water, you can expand the area under irrigation. So the government also has given certain schemes. That means if you want to enhance the area under irrigation beyond this area also, how we can give certain schemes using certain pumping mechanism, using non-conventional energy. And such schemes are also available based on these studies. So this is one in Telangana Jorala project. And you can monitor these from the satellites. And these are all available in the specific state government websites. And this is on the power of the Panchayat Raj, because Kerala also, we have a lot of Panchayat Raj system is very strong. So we made a space-based information support for decentralized planning. That means the scale of 10,000. We mapped all the themes on land use, land cover, and also on the information, the soils, etc., that and the land degradation at 50,000 scale, and attached to it to make the plans. But and then there are certain 281 assets in each village. It's supposed to be there on a panchayat. If there's not there, we allowed people to, students especially helped in finding out how many assets are there, and the assets are not there, how we can make it plans for making those assets. And to train the panchayat level workers as SATCOM, satellite communication facility at every block. Some of the states have taken it. They see online this information and what is that gaps which they have, how to plan. But this is not possible for them to plan by themselves. Here, this is where another data analysis opportunity available for youngsters like you. Once you become your own in any discipline, irrespective of either engineering or commerce or any other economics, you can do so many activities of this nature. And similarly, like urban areas has what is called local bodies. So for these local bodies to plan, previously we did a National Urban Information System. Today there's an Amrut. You also heard there's Amrut cities, some 500 Amrut cities. So they have been trained by the local bodies will do this planning process. That means whatever the maps generated from the satellite data are available for these urban local bodies who are authorized to prepare their own plans, and they put it in the public domain, and public can give comments on the town specific on their views. And then there are also site suitability, environmental conditions also have been looked into while making these plans. So there's a good opportunity for people to plan for themselves. This is what the 73rd and 74th amendment of our constitutions, very important constitutions. So that what tells the local bodies and panchayats can plan by themselves, should plan by themselves, and the finances are directly given to the panchayats and the local bodies. There's no state and barricades here. So that is how the information flow is needed for them to train and use. So there may not be a full potential to use. That's where youngsters like you can future. You can be town planners, you can be or a panchayat level rural development planners. You can do many of these schemes. This is where I would like to show you the government. That time is this is in 2015. They launched a program called Greening Eastern India. Why Eastern India is many a time we find after the Kharif season, because you all know we have Kharif, that is in the monsoon season crop, and Rabi basically on the irrigation, that is the winter crop. So there are a lot of post-Kharif fallows are there, rice fallows, what it is called. That rice fallow has a moisture, and that moisture can grow pulses. And for that, whether the pulses, it is possible or not, the entire Eastern India. So this is only a 3 days job. All data what is published on Bhuvan, same data has been used, and 3 days, within 3 days, this information could be provided for the state governments to understand where is the potential areas available for making that. So 8 lakh hectares has been identified as a potential suitable site. Though this is available, but access to resources is not there. So the green, whatever dots you see, and this is you can blow it into village. As I showed you at a cadastral level, the information is available for this particular state, Chhattisgarh. So they can go through, and what is the yield and gross income, everything can be put through. But this is not a one-time affair. This has to be done every year. Who is going to do this job? Neither the agriculture specialists are available to do. As a consultants, people like you, youngsters, can use different data analytic techniques to do that application. So it's a very big, good opportunity as a business opportunity. Not only in India, you learn, but you can go anywhere in the world and do it for yourself. Similarly, because we are an agrarian society, but agriculture fails because of the monsoon fails. So the second livelihood option which has been given is horticulture. There is permanent tree crops. Suppose if you have a permanent tree crops, even the rainfall is not good, but still the farmer doesn't go below the pot line, taking that as a second livelihood option. But after seeing these outputs, the Prime Minister has announced that we should have these inland fisheries as one of the part of Blue Revolution. Blue Revolution has some part in the inland, some on the ocean. Ocean is for cage fishing, etc. But on the land, we have what is called inland fishing. Kindly see, this is a part of Chhattisgarh. One state itself in one district is only 10,000 square kilometers of area. If you take half hectare to 10 hectares, almost more than 5,000 tons of fish will come out of that. But that should be an organized structure. That means you cannot expect the full growth to happen. That means you have to make a fingerlings. That fingerlings has to be taken into the ponds. That means like it's an industry for fingerlings. It is for the fish. Within 3 months, you have to harvest, and harvested one has to go to the market. So you have to have processing units. So it is not just fish alone, but ancillary industries which are needed to do this activity. So much of employment opportunities are available within the India, fully still not explored, and government is giving a lot of funding for such aspects in our country. So this is called part of the Blue Revolution. So this is where the government investments are there. This is where any of you have interest on fisheries or biology, zoology, and also want to link with some kind of information processing, and you have ample opportunities. The most important is the crop insurance. Why crop insurance is? Because we know our agriculture system can fail because of many calamities. It can be because of the failure of monsoon or non-availability of water, or there's a certain amount of risks. The farmer takes a lot of risks in his agriculture practices. So government has made compulsory for insurance. So there are 8 areas you can use space technology. That means this is for premium. For any insurance, there's a premium. Because some of you have bikes, etc. You know you have to pay an insurance premium. Similarly for this. So how many people are covered in the insurance? What is the crop growing risk within the 1 month? Discrepancies also. And finally, the yield and verification. So all these areas, there is a possibility. Today, it takes almost like 3 to 4 months to pay back. But then you should opt for within 7 days, you are able to solve and give the insurance claim for the people who are affected. That is the best system. So there are 8 companies in the country, 2 are public sector and 6 are private. All are looking for this data analytics. And data analytics is one of the important area and of economy, and also for professionals like you who are going to be professionals in future. This is one of the major area of opportunity. And this is about using a mobile itself, mounted on a vehicle, on a car, and put through, you can mark what are the areas which are, because your mobile is so sensitive, it has a gyro instrument, it could map exactly the damaged roads and moderately damaged, to government to take a decision how to do, where, and things like that. You're also hearing about the locusts, right? So this has been done in Kazakhstan in 10 years back. We did this for Kazakhstan to show which are the potential areas where the breeding grounds happen. Why this is important is, for example, see this insect. It is going to 5 to 7 centimeters. It is putting its tail. It is sensing what? Soil texture, soil temperature, moisture, hardness, salinity, and also outside it looks for the bushes and other covers. This is where it lays its eggs. So this fellow is very intelligent. So to make this a similar instrument by yourself using your payload, whatever is very much important. Can you do that? Today we do it from satellite-based information. on where is the soil moisture or where is the vegetation and soil texture. These are all done by satellites. But then there's a mechanism which is needed, an insect, a small insect which is able to do. And here you have an opportunity. That means there's a life cycle for it. Breeding, flight suitability direction, and egg development and hooper stage. These are the areas, if you are able to eradicate, the swarm will not come. So instead of looking at the swarm, where the swarm going, using drones to monitor that, if you are able to identify this, you get a lead time at least of 50 days in which you can eradicate at the where it is, where is the site where it's for laying the eggs and making the hooper stage. So we can know the problem at the problem stage itself. We can do. There's a bulletin which is coming from NRSC, a regional center at Jodhpur, is now continuously bringing the bulletins on this. This is what similar to you have a produce which is coming from one location, but how this produce will go move to different places. This we did for IFCO. You might have heard a company called IFCO, which is a fertilizer distributor company. So where it makes a fertilizer, that fertilizer from how it will come to the warehouse, and from warehouses, how it is going to the stores, how many stores of their own, the leased ones. And to make it more economical, we have to see an inventory of it and capacity and sales position. So you're not talking about just space. Space gives you the information regarding what crops are suitable in a given area, and also the information on the weather, which tells you how the crop growing period, CGP is crop growing period, how the crop growing period is shifting, and accordingly what type of fertilizer is needed for which crop. This becomes the crux of the problem. Today, government also has launched a program called crop health cards, that is soil health cards, that talks about the micronutrient deficiencies. These micronutrient deficiencies, you can make a micronutrient blend, but this micronutrient blend for sugarcane it is different, for banana it is different, for paddy it is different. So there's a ample demand for all such allocations. But then you have what is called allocation and optimum routing. This is resource allocation. So this is what the Flipkart, Amazon, and if you see many of the people who have certain experience, a graduate, an experience in GIS and with programming skill on Python, they are hired at a much higher level than what you can expect. So there are so many opportunities of this nature, not just for fertilizers, but any resource to move to the user's hand. And today in the pandemic like this, all are waiting for online. Everything has converted into online procurements. So everyone has to do similar side of things. So these are all done through a GIS and GIS modeling. And this is for online nuclear emergencies. Suppose there's a radiation leak. This has been done for in Kalpakam nuclear plant. So if a radiation leak comes, these blue lines are all the village boundaries, and this is the plume which is moving. And then this is in the ocean. This is the Bay of Bengal. So how it moves and comes to the land. So based on that, we can look up what is the ground deposition dose and what are the precautionary measures who to do. So this is a real-time system for 72 hours before. It takes the inputs on wind vectors and from their own stations and give these prediction models. So this simulation can be on your handheld device like your mobile. So and then make your production mechanism. So this is where the things are, and this is all done through indigenous software. There's no commercial software here. So there is also a called precision agriculture. So this is for in terms of water, pesticides and fertilizer use, and variable rate at which we have to use these things, because for this, as I told you, our land holding sizes are very small. They're varying. So how to optimize these resources? So the less usage and more yield, then your profits will be much higher. And every farmer is looking for such inputs as an advisories. And there's a lot of business. In fact, the crop insurance, a small segment, is being done by Sakshetra, a startup company which has been, and they are alumni of IIST. And this is where, but you're not looking for such. You want to become smart. Everyone wants to have a smartphone, smart cities, smart villages, smart health care, and smart agriculture like that. So this is where the wisdom plus technology, including innovation. So there are a lot of opportunities for you to do, but then when you want to do on smart, you get huge amount of data, and the data is having a variety, and there are not structured data. There is semi-structured, unstructured data, but this variety of data and volume you have to process to give information on near real-time. That means you're walking, you should get a result. Is it going to rain? If it is going to rain, what I'm supposed to do? I'm going to harvest. where I'm going to keep the harvest produce, and what else we can do. This is the opportunity. I'm telling you, this is a very, very big business. Making satellites is not a big business. Okay, the amount spent for satellites or launch vehicle is not big. As I told you, a 1 lakh crore application is running with a geospatial application. 1% of it, if you are taking of 1 lakh crore, what is your returns? Please understand. Any application you are trying to show the government that the good governance is on whatever the processing. This is where we could get funds from. I'm not telling this is a theoretical situation. We could get 5 rupees per hectare from Maharashtra government to implement a scheme, and which will give it returns for them per hectare 3,600 rupees to 900 rupees variable. That means if he is having a bore well, it is 900. He is using irrigation water. So what is the crop water requirement and how much water he is using? A water cess has to be paid, and that is the application. And today, because of the 3-tier imaging, what was done 5 rupees per hectare is only costing now 50 paisa as far as the data and processing is concerned. That means you invest 50 paisa, you make a profit on top of it. Each of the state governments are looking for the water use and how to put water cess. They're collecting water cess in different places. Similarly, in another state, it is 10,000 rupees broken into 5,000 rupees per year. So a project of 20 crores has been done in Chhattisgarh to get all the cadastrals and other things. So every state is looking for such information which they would like to use it for the benefit. So whatever we looked at is where is and what mapping. This is descriptive. But in future, it is why and so what. That is modeling. That means we are looking for prognostics, early warning, or a predictive analysis. This is what we are looking in terms of food and water security, infrastructure planning, environment and energy security. For all this, a variety of data is available in India. No other country from a governmental system where you have such huge data for most of the electromagnetic spectrum, which is imaged both from radars or from multispectral, that what we call as optical imaging. Everything is available. Only it is for you to make certain sensors in the field. And then how do we connect these in situ sensors? There's a lot of scope for you to do. Some of you are interested in physics. In fact, one of my colleagues speak about Umesh and all, they'll tell you how they're making some indigenous sensors. Okay, what is the value of it in terms of commercially, they'll help you. This is what ISRO's vision, as far as Vikram Sarabhai, he looked always for the problems of the people and the society. And for us, in up to 2030, this is what the time what we talk about: food security, water, energy. I didn't touch because of lack of time, but energy, non-conventional energy, solar, hydel power, wind, all there are applications in that. Similarly for health, shelter, even the malaria infested areas, so many things are being done. And infrastructure and information. This is where on Bowen, we are giving all the information from the satellite which is coming in. Then the governance, whatever you plan with the right inputs, if you plan and you know what its impact, so monitor and evaluate it, and a decision support for such. And disaster risk, we are doing early warning and response and rehabilitation, but preparedness is also very important. These are the two important areas where you have ample opportunities which you can look for. And also in sustainable development, that means any act which we do, either in agriculture, urban, coastal ecosystems, fragile ecosystems, all has an impact, and also climate change induced impact. This is where the independent bodies we would like to do, especially academic institutions, are encouraged to take up such studies where the data will be made available from ISRO for such activities. And these are the future. ISRO has a long line of satellites. It is not just a few satellites which has been launched. Here you can see in the bottom, there are Cartosat series 3, which is 25 centimeters. One of the best in the world is available with India, and with all indigenously done optics to everything. And also the Resource Sat series, 3 series, GI Sat, high resolution. That is every day you get in information on high resolution. This microwave, Ocean Sat. This in NISR is a joint collaboration with NASA. We are making a satellite for microwave imaging, L and S band. That means it penetrates under the surface of from the surface of the Earth and gives you a lot of information. So it's NASA and ISRO's collaboration. In 2021, the satellite is going to fly, and huge information is available. So for youngsters like you all, where God has given you one country with diversity of ecosystems, you have Eastern Ghats, Western Ghats, East Coast, West Coast, And the continental shelves are also different. We have islands, we have cold deserts, we have sandy deserts, and we have the northeastern hills, because that's a relief length ratio for the river systems are small, and here you have bigger river systems. So God has packed everything, many languages, so much of diversity has given for you to experiment. Anything you experiment in highly heterogeneous environment, you go and do it in a homogeneous environment where most Europe and Western countries and all are there, it is easy to do any modeling. I need not to tell you, that's a common sense part of it. So you have a great opportunity being an Indian to do all these analysis and the opportunities which are available. And I thank you for your kind patience hearing. I know the afternoon session, because it's after lunch, it's not that easy to put through. So that's where I told I will show you a flare of applications which are there. Few of them I try to explain and tell you. But then most of these things you study in 10th, 11th, and 12th. The fundamentals you already read through, okay? These are only the applications of it. How an image can be broken, how an image is, how you can break into not the spatial, but also in the frequency domains, how you can do the corrections, and how do you process this huge terabyte, this is petabytes of data. In analysis now, we have petabytes of data. And all is for data analytics, because the next century economics of the world is on data analytics. So most of you who have a fascination for physics, or for chemistry, or for biology or botany, or for economics and commerce, ultimately look at what, after understanding, enjoying a subject, what application you can do. So it is good for the society, and it gives you a livelihood, and you can become an entrepreneur by yourself. So you're no longer a job seeker, but a job creator. Whatever applications I've shown you, everywhere you can become an entrepreneur. So this is where my catch for you is, and also your national education policy has talked about interdisciplinary research, interdisciplinary education. So that is the greatest opportunity for all of you kids who are all getting into their professional courses. So choose carefully, so that it is not that you have to do an engineering discipline, you have to do a medical discipline. You can also turn into your arts, your culture, your music, whichever you want. You can take, which will give you added credits for it. But unless you have multidisciplinary research, it doesn't become a product, or else it becomes a good publication. So if your multidisciplines are there, you know of an indigenous product and how to sell this product, what are the legal implications when you tell about a product, if you're doing in India or you're doing across the globe. So all this you can learn when you're doing your professional courses. Once again, thank you for the opportunity given by this team for me to interface, and then maybe we'll have more interactions in future when you ask questions. Thank you.
Thank you, sir, for the wonderful lecture.
Thank you, Professor Krishnamurthy, sir. It was a enriching and motivating session. On behalf of IIST and the Sargakshetra Academy and Charitable Center, Charitable, and the entire participants of IIST at School Program 2020 Beyond the Horizon, we would like to extend a sincere thanks to Professor Krishnamurthy, sir, for your inspiring, motivating, and enriching session. Thank you so much for thank you. And next, we have a theme lecture by Dr. Kuribula Joseph. He serves as a Dean, Student Activities and Student Welfare Outreach of IIST. I'm sure you will get more practical knowledge and practical inspiring session by him. On behalf of IIST and Sargakshetra Academy and all the participants of Beyond Horizon, we welcome you, sir, for this session. And over to you, sir.
Yeah, thank you so much for the nice words. In fact, I would like to talk on fascination of science, since our director and registrar Vaiven Krishnamurthy, sir, both of them explored the space in very detail. So what I am planning is I will go through some of these scientific inventions which changed the life. So some of the life-changing achievements. Then I will talk on the nanomaterials, nanotechnology, and finally how this nanotechnology or nanomaterials can be used for the development of the new world. This is the content of my talk. Prior to that, let me introduce our institute, IIST. Indian Institute of Space Science and Technology, under Department of Space, Government of India, established in 2007. This is our emblem, the logo. You can see a rocket launching, and this is a trajectory, and you can see a satellite, and this is the orbit, and where you can see the Earth also. This, in fact, one of our students, we made a competition, and one of the students designed this logo. And ours is deemed to be university. As I told you, it's under Department of Space, Government of India. And presently, we are offering undergraduate, postgraduate, doctoral and postdoctoral programs in the areas of space science and space technology and applications. And our director and registrar have given a very good talk about space science technology, the basis and applications. And actually, in our institute, we are having 3 undergraduate program: BTech in aerospace, and BTech in avionics communication engineering, and we have a dual degree program, that is BTech plus MS or MTech in various space science and technology. And we are taking students through IIT JEE Advanced. And one good thing about our institute is if you got admission in IIST, and if you can keep a CGPA of 7.5 in every semester, the expenses will be met by Government of India. There is a assistantship. So one should keep a semester CGPA of 7.5 each semester. So if first semester, if you keep 7.5, you will get that money reimbursed, and their expenses, including the hostel, food, tuition fee, and everything. And on successful completion of the course, depends on the vacancies in ISRO's center, there's a chance to get absorbed in ISRO. That is another interesting thing. So if you are keeping very good academic performance, you don't need to pay money for the studies, including your food accommodation thing. And on successful completion of the course in 4 years with a 7.5 CGP and above, depends on the vacancies in ISRO centers, there's a chance to get absorbed in ISRO scientists, engineers. In addition, we are offering various master's program, MTech and MS programs in various disciplines, in aerospace engineering, in avionics, chemistry, earth and space science, mathematics, physics, etc. And the admission to this MTech program is usually through GATE, and this number of candidates are more written test plus interview. And the PhD admission, we are having a research program in almost all areas of space science and technology. And research is again based on the GATE, CSER, UGC, JRF, JUST, etc. Sometimes depends on the number of candidates, sometimes we used to conduct written test and interview also. And some of the positive takeaways of IIST, it is the only institute in the country, probably in Asia, offering undergraduate, PG, and doctoral, and even postdoctoral program in space science and space technology. So it's the only institute in the country. And we have a national character of students with the UG students coming from 22, sometimes we got 24 states representation. And we have a very good teacher-student ratio, it is 1:7. And we have a strong, because it's a Department of Space Institute, we have very strong linkages with ISRO. Students can undergo project, take their project internship in ISRO centers. And our own students designed and developed and launched a sounding rocket with the help and guidance of Vikram Sarabhai Space Center scientist in 2012. And currently, a couple of nano satellites are developing in the institute. And students are getting very good exposure to various space, science, and technological applications. We have a space where is a miniature type of or nano satellites and launch vehicles. So those things are developing. So students will get hands-on training on all sort of things. This is a master plan of IIST where you can see this is our academic campus, where you can see all the hostels. We have several hostels for boys and girls. This is our student activity center where with various indoor stadiums, open air theater, and big dining mess hall for the students, and multi-purpose hall. And this is our administrative block, and this is our library, beautiful place. And this is our aerospace building. This is our avionics building, and this is our interdisciplinary block, and this is our physical science block. Another campus opposite the road, we have the student activities, students football or cricket stadium and faculty quarters. Altogether, nearly 100 acres land in Valimala. We have another campus at the top of Ponmudi Hills, and you can see some of the buildings of our institute. This is the library. One of the best, beautiful place of IIST is the library, 7-storied building. And good thing about this library is almost a student, one can say that it's a student-controlled library. That means students can take their mobile phone or laptop or textbook. There is no control. But every year we are taking the stock, and 100% stock is there. And this library is connected to almost all ISRO centers. So people can access books or journals from other places also. And this is one of the hostels. As I told you, we have several such hostels. This is one of the boys' hostel. We have 24/7 medical assistants in the campus. And this is one of the girls' hostels. And yeah, we have since we have students from more than 20 states, we have a buffet system. All the meals are a buffet, and students can have the choice of selecting the food. And in addition, we have a private cafeteria also within the campus. We have a very good water harvesting system, and the entire water requirement for the campus is we are saving the water from this small lake. So I am from the chemistry department. We have established beautiful laboratories. In almost all departments, we have excellent laboratories, and students are getting hands-on training on all spectral, analytical, mechanical, whatever be the almost all sophisticated equipments. The idea is that once the students are going out from IIST after 4 or 5 years, mostly they are going to join in ISRO. They will get adequate training in operating all the instruments and equipments. And this some of the PG laboratories, we have a good nanoscience and technology laboratory. We have a good materials characteristics laboratory, and we have a polymer processing laboratory and things like that. So welcome to IIST. All of you, please try to get admission in IIST so that you can get trained and come out as a good space scientist, and you can work. If you are very good, the vacancies are there. You can work for ISRO, and you can serve the nation. Thank you. So my dear students, coming to the talk, if you look back the history of science and technology, one can say almost 60 to 70% of the inventions or discoveries happened because of these two things. One is curiosity, other one is utility. So almost 60 to 70% of the inventions happened only because of curiosity. That means from the beginning, people were really curious to know the secret of nature. They were really, really curious. They were trying to explore the science behind it, the fact behind it. We have a lot of examples. You know, Sir Isaac Newton, he was really curious why the apple or the fruits are coming down, why not it's going up? And because of his curiosity, finally end up in discovering the gravity. So we have a lot of our own Raman, C.V. Raman. He was really curious why the sea looks blue. can see thousands and millions of people have traveled the sea over the years. But only one Newton was really curious about it and finally end up in discovering the Raman effect. You know, nowadays, Raman spectrometer is one of the important tools in all areas of science and technology. So when you are talking about research, when you are talking about science, technology, or humanities, wherever, whichever be the subject, one should be curious. A curious mind is a dynamic mind. So I used to ask students, what is your goal in life? What is your goal in life? Goal in life is, I am studying +2 and I am aiming for IIT JEE or IIST or NIT, or sometimes I am aiming for medicine. So after that, what is your aim? If you are a medical student, next aim is to go for post-graduation or super specialization. Imagine that my aim is to become a cardiac thoracic surgeon with MGH in cardiothoracic or neurology. And I could achieve that MCH at the age of 30 or 32 or 35. So my goal I achieved at the age of 30, then what next? What next? 90% people next is to buy a car, buy a house, and their focus is entirely changed to have a happy life. So goal in life actually to have a happy, comfortable life. Because I achieved. I'm aiming for IIT. I could get an IIT BTech degree at the age of 24 or 23 or 24. I can also go for MTech. That's all. So our focus is mainly on money-oriented, happy, comfort life. I'm not against it. That is needed. My dear students, actually, the real goal in life should be something different. The real goal in life, if I quote the great Abdul Kalam sir, the real goal in life should be, after my time, after my death, how I am going to be remembered. How I am going to be remembered. Whether I am going to be remembered or not. I used to ask students, can you name the name of your grandfather's father or mother? Can you name? I know 95% won't know. That means your own grandparents sacrificed their entire life for your own parents and you are not able to recollect their name. So that means after my time, if I am not going to be remembered, my life no value. I am really blessed with a lot of potentials and talents. If I am not going to utilize it to the extent what I can, I have no use. So what I am trying to tell you is that the real goal in life is something different. Not to get a job, not to have a car, not to have a house. Real goal in life is my contribution should be, my name should be remembered forever, even after my time. I should be remembered. If you type your name in the Google or any other search engine, how many hits are about you? Maybe 0, maybe 1, maybe 5. Forget. You are students. But my dear friends, try to fix the target that by 2040, you will have thousands of hits about your contribution. If you type your name, hundreds and hundreds hits about you should come out. And that is going to be remembered forever. So my dear friends, try to contribute to the society. Whatever be your field, whether it is science, technology, humanities, whatever be the field, try to excel, try to perform outstandingly, and you will be remembered forever. So my dear friends, be curious, and curiosity is the driving force for all achievements, all inventions, all discoveries. A curious mind is a dynamic mind. That's why be curious always. When you are reading something, when you are doing something, when you are observing something, always be curious. Always you should have an out-of-box thinking. And one more request, don't be so reverent to your supervisors or teachers. You should respect them. At the same time, you should be irreverent to ask or pose questions. You should ask questions, pose questions, so that these questions will emerge as a new problem, and you are going to solve the problem, and you are going to solve, or you are going to do something great to the society. With this, let me go through some of the life-changing discoveries happened. You can see that a great scientist, Nicolaus Copernicus, in the year 1543, while on his deathbed, he established that the sun is a motionless body at the center of the solar system, with the planets revolving around it, including the Earth. You know that till that time, people believed that Earth was the center portion and all planets revolving Earth. So he was really curious about the solar system. And his curiosity finally ended up in establishing the theory. And you remember, while on his deathbed, he was on his deathbed. So that is the real curiosity. All of you might know about this Copernicus system and things like that. I don't want to delve into that. Another interesting observation is Charles Darwin, the theory of adaptation, and it was one of the life-changing theory. Then, as I mentioned earlier, we have Isaac Newton. See, in 1664, Newton figured out that gravity is a force that draws object towards Earth. And he was curious about, as I told you earlier, he was really curious about why the apple is not coming down, or mango is not coming down, why coconut is not coming down. This question enabled him to discover the gravity. So this is a very famous statement of Newton. And then Dmitry Mendeleev, last year, the entire globe celebrated the 100 year of periodic table, Dmitry Mendeleev. See, another life-changing. Can you imagine a world without the periodic table? Almost all material science development happened only because of this periodic table and its property. So Dmitry Mendeleev, the Russian for few elements identified. So he was able to, so Dmitry Mendeleev arrange those elements in a periodic way. So it was a real life-changing discovery. Electricity, another great life-changing discovery, Michael Faraday. So all of you know that Faraday invented this discovery. After inventing all this discovery, then British Prime Minister asked him, Mr. Faraday, what is the earthly use of your discoveries? You are saying that you discovered dynamo. What is the use? How it is going to benefit the poor? Then then Faraday replied, Mr. Prime Minister, one day you or your successor would be able to impose taxes on the public for using the benefit of my discoveries. Today, everyone knows what electricity tax. Moreover, can you imagine a world without electricity? Not only electricity, all your mobile phone, all everything, the basis is electricity. The modern world depends on electricity, energy. So great man Faraday discovered. Another important thing is Avogadro number. And this changed a lot. Telephone, Alexander Graham Bell, you know that Elisha also discovered the same thing, but Graham Bell was lucky to pay, they submit the patent in the right time. Alfred Nobel, another great man. And then X-ray. And you know, X-ray is giving lot of support to the modern science and technology, not only for the medical field, other area also. So Roentgen, Henry Becquerel, radioactivity, and one lady got really inspired and she got 2 Nobel Prize. There is Marie Curie, Louis Pasteur, Einstein, oh, wonderful scientist. You know, in a single year, 1905, known as Einstein's miracle year, and he formulated the special theory of relativity, established the law of mass energy equivalence, created the Brownian theory of motion, and also formulates the photon theory of light. From a single brain, lot of theories, fantastic. So those people were really curious. They dedicated their life for science. And finally, it's a very famous quote by Einstein, I want to know how God created this world. I am not interested in this or that phenomena, the spectrum of elements. See, discovery of insulin, Alexander Fleming, Janssen, and a lot of quantum theory, Niels Bohr. Quantum theory is the basis of nanotechnology and modern technology. And Haber process and Big Bang theory and Charles Babbage computer. Without computer, nobody can imagine a world. Atomic bomb and Raman, our own Raman. See, with the 200 rupee spectroscope, he could establish Raman effect and got the Nobel Prize. Our own Raman. And another great scientist of India, Jagadish Chandra Bose. Actually, a physicist turned into a biologist. And he was really curious, worried about the plants. And he contributed a lot. Microprocessor, television, and you can see that our director started the talk with the Sputnik one in 1957 and Apollo mission and Viking, things like that. Just a minute. Thank you. All such things happened, and we can see that DNA, another breakthrough in our science, and Microsoft, NASA Columbia Space Shuttle, and scanning tunneling microscope, and lot of things, Mars Pathfinder, and our own India's great mission, Red Planet, Mars mission, and Chandrayaan, and all those things. A lot of new technologies, new challenges in science and technology, nanomaterials, fiber optics, microelectronics, laser technology, biotechnology, atomic energy, electricity, ocean research, ocean resources, space research, etc., etc. Today, why I told you that? So all these areas, all those scientists really inspired us, ignited us, motivated us. So they lived They sacrificed their entire life for the society. That's why all those names will be remembered, are remembered and will be remembered. My dear friends, try to aim a life just like that. Your goal, you may please rewrite your goal. The goal should be, after my time, I should be remembered. My contribution should be remembered forever. My name should be remembered forever. Einstein will be remembered forever. Raman will be remembered forever. Mahatma Gandhi will be remembered forever. So that is the real goal in life. So I will talk something about nanomaterials and some of the applications in next couple of minutes. A peep into nano world. So all of you know that nano is something very close to atoms and molecules. This is an atom. This is a molecule. You can see that hydrogen is there, oxygen is there, carbon is there. Whereas I have a fullerene is a nanomaterial. That means when I am talking about nanomaterial, it is so tiny, it is very close to the size of an atom. Look here, I have a size comparison. Here you can see 1 angstrom unit, and here 1 centimeter unit. Under 1 centimeter, I have tissue and organ. My heart, lung, liver. So my bacteria, if we are looking about the bacteria, it is 1 micrometer. Whereas nowadays we are talking about Corona-19 virus. It is size is something about, say, 1 nanometer to 10 nanometer. So nanometer or nanotechnology is a science deals with the materials whose one of the dimensions should be in between 1 nanometer to 100 nanometer. 1 nanometer to 100 nanometer. It may be diameter, it may be thickness, it may be length. So those materials coming under this size regime, we can call it as nanomaterials. Or look here, I have water molecule. I have a tennis ball. And my nano device or nanoporous materials are coming very close to water molecule. Water is nothing but only 3 atoms. So my nanomaterials or nano device is very close to this molecule. Look here, I have, you can see different types of balls, and this blue ball represents a red blood cell, size of a red blood cell. And these are my nanomaterials, size of nanomaterials. One can have a very good comparison of nanomaterials. You can see there, it's very, very tiny compared to a red blood cell. Or look here, I have 3 boxes of equal volume and size. This is first box. In the first box, I am trying to put particles of 10 micrometer, say pepper. So I can, for ease of understanding, say 50 pepper, I could incorporate in the first box. Then I reduce the particle size of the particle from 10 micrometer to 1 micrometer. Same volume, same area, I can incorporate few thousands of particles. So when I reduce the particle size from 10 micrometer to 1 micrometer, number of particles per unit area increased from 50 to few thousand, say let it be 5,000 particles. Again, I'm going to reduce the particle size from 1 micrometer to 100 nanometer. So when I reduce the particle size from 1 micrometer to 100 nanometer, number of particles per unit area, same volume, same area, increases tremendously. When I say tremendously, 5,000 become 5 million. So now I have 5 million particles, the same area, same volume. What is going to happen? Each particle is having a surface, and I can calculate the surface area of each particle. So surface area increases tremendously. Reactivity increases. Moreover, the physical properties, the chemical properties, will change. Look here, some of the size-dependent properties, optical properties, electrical properties, physical properties, and chemical properties will change. So bulk gold, the gold is gold because of the yellow color. If you reduce the particle size of gold in the nano, yellow become wine red. The color will change. The particles are so small that electrons are not free to move about as in bulk. Because of this movement is restricted, the particle react differently with light. So simply by reducing the particle size from micro to nano, the color change, the properties change. Zinc oxide, the micro particle size, it can block UV, scatter visible light, and appear as white and opaque. Same zinc oxide, if you convert into nano, it will block UV, but it will become transparent. Why is transparent? Because the particle is so small compared to the wavelength of the visible light that does not scatter. And so, see, simply same zinc oxide, when I converted into nanoparticle, it is acting as a UV blocker. At the same time, it will act as a transparent material. Some of the properties are meaningless. You see, boiling point is meaningless because when I'm talking about nano, vapor pressure becomes less and less meaningful when you have smaller and smaller number of particles. So when you say 50 molecules or 100 molecules, there is no bubble. There are no bubbles. So such cases are also there. Gravitational forces become negligible and electromagnetic forces become dominant because I'm talking about few atoms, molecules. Quantum mechanics is used to describe motion and energy instead of classical mechanics. Greater surface to volume ratio. Random molecular motion become more important. See, by changing the particle size from micro to nano, lot of physical properties, mechanical properties, electrical properties, optical properties, chemical properties will change. So this is the beauty of nanomaterial. There are a lot of nanomaterials, nano devices. One can think of nanocrystalline material, nanoparticle, nanocapsules, nanoporous material, nanofibers, fullerenes, nanotubes, nanodendrimers, and it can be used in molecular electronics, can be used in NIMS, nanofluids, nanophotonics, nanooptics, nanomagnetics, etc., etc. It's a wide area. It's a fast-growing area. Nanomaterials and nanotechnology. In all span of human activity, starting from aerospace, space, energy, medical field, agriculture, all sphere of human activities, nanoscience and nanotechnology are entering. And this is a very, very important, it's a breakthrough spectrum. In fact, this spectrum, in fact, changed the recent science and technology history. All of you know that. Proto and his co-workers, they were doing some laser experiment on graphite. They observed this mass spectra of 660 and they were really curious. It is unusual to get a spectra of C60, carbon 60. They repeated the experiment, they were getting the same spectrum, and finally they searched and finally end up in discovering the fullerene. You know that? 30 years back, this poor man, graphite, only 2 uses. One used as a tip of the pencil, and second application is it is used as a lubricant. Now, if you search the science director or any other area, you can see that thousands of publications are coming out with the graphene. graphite oxide, carbon nanotube, and things like that. So you're laughing that graphite and diamond, now you have fullerene, and people are talking about the diamond, graphite, C60, C70, and the carbon nanotube, endohedral, and graphene. Wonderful material. Graphene is nothing but if you can separate a single layer of graphite, that is what is called graphene. And if we can fold the single layer for the ease of understanding, let me say, if we fold the single layer of graphene, I could get single wall carbon nanotube, and if you are folding multiple layers, I will get multi-wall carbon nanotube. And this is about carbon nanofiber. My dear friends, last century, smart fibers were carbon fibers and tubular fibers. Because tubular fiber is having very high strength and modulus, and it is acting as a bulletproof material. Carbon, on the other hand, again, it is having very high strength and modulus, but at the same time, it acts as a high temperature withstanding material. It can withstand a temperature of 2000 and above. So that it's a thermal protection system. It can use it as a thermal protection system. So you know that if I say 2000 to 2500 degrees Celsius, one can imagine the magnitude of 2000 degrees. I used to tell students in a winter season, if you want to take a bath, what could be the temperature of the water? Once I asked the question and one student said, sir, it is 90 degrees. I told them, it is going to your last and final bath because 90 degrees can kill you. See, 1100 degrees is the temperature of electrical crematorium where one human dead body will become ash in few minutes. Then you imagine 2000 degree or 2500 degree. So this fiber can withstand that temperature. Then carbon nanotubes, as I told you, if you can have a single volt, if you fold a single layer of graphene, we'll get single volt carbon nanotube, or if you can have multi-volt carbon nanotubes and things like that. It's a beautiful material. And look here, this is my carbon nanotube, and this is my C60, and the diameter of the C60 is very close to the elemental atoms. Carbon, the diameter is 1.54 angstrom, and nickel it is 2.5, and my C60 is having 10.8. That's why it is very close to molecules and atoms. So when you say I'm working on nanomaterials and nano device, that means I'm going to play with the atoms or molecules. So this is now people are trying to develop super carbon nanotube. Carbon nanotube itself is a wonderful material. It's a wonderful material. Scientists are not satisfied with that. They're trying to develop a carbon nanotube, which is made up of carbon nanotube. All the hexagons are made up of carbon nanotube. That's the real curiosity. People are really curious. And scientists are the greediest people, and they should be like that. And as I told you, graphene and wonderful material having a lot of interesting properties. I don't want to delve into that. Then another interesting thing is quantum dots. Quantum dots are small particles of semiconductor material. Typical dimensions ranging from most of the system is 1 nanometer to 10 nanometer. So that means just like an atom, it is having energy levels are quantized. Its energy levels are quantized due to the confinement of electrons. You can see that energy levels in quantum dots are quantized, confined, and it can be used for a lot of applications. So depends on the size of the quantum dots. One can have a different color spectra. If you want to make the display device of display of your mobile phone or laptop, so you can use it because I can have various color, depends on the size of the quantum dots. That's the beauty of quantum dots and a lot of other added advantages. And my dear friends, people are trying to modify. I have thousands of nanoparticles. If I want to use it as a sensor, if I want to use it in a structural application or communication or whatever be, I want to modify it. A lot of modifications are going on, and as I told you, we can have this technology can be used in energy, medicine, nano biotechnology, nano devices, optical engineering, defense and security, bioengineering, cosmetics, and nano fabrics. One interesting thing I will tell you, super hydrophobic and lotus effect. All of you know that this lotus leaf are known as symbol of purity. It's a water resistant. It's a self-cleaning material. Why? Because this material is having a nanoporous structure, nanoscopic structure, surface structure, where it can act as a super hydrophobic material. A super hydrophobic material means if the contact angle is more than 150 degree, we can call it as super hydrophobic material. If the contact angle is less than 90 degree, we will call it as hydrophilic. If it is greater than 90, we'll call it as hydrophobic. But if the contact angle is greater than 150, we will call it as 150. It is a super hydrophobic material. And super hydrophobic material is a wonderful piece of research where I'll come to some of the applications. See, this is a case with the lotus leaf or lotus flower. The surface is nano structured. The water droplet will simply roll out just like a football. Along with the water droplet, all the dirt also will go. So that's the science behind it. A lot of people are working on this lotus effect or to imitate lotus leaf or lotus effect on materials so that I can make super hydrophobic paints, coatings, and materials. And this is a mechanism. If I have a water molecule and these are the dirt particles, this water drops will roll out and it will take away all the dirt also. And I can have a self-cleaning material. So if I have a super hydrophobic coated boat, because no addition between the water, so no friction, it can have a very high efficiency. In the skiing, or if imagine that I have a super hydrophobic coated car in windscreen and paint. So simply pouring water, all dirt will go. If I have a super hydrophobic coated clothes, simply dip in water, take it out, all dirt will go. So it's having a wide application, and a lot of people are working to develop super hydrophobic materials for various applications. Some of the next, I will show some of the applications of nanomaterials in medicine. As I told you, these are my red blood cells, and my nano device or nanoparticle is having only this size. Then, if you see, this is a cell. My nanoparticle will be a spot in that cell. That means my nanoparticle or nano device can easily penetrate into the cell without disrupting the cell structure. Imagine that. Say some years back, if I say some 30 or 40 years back, somebody is having a tumor in the body, the diagnosis is mainly based on the physical examination, symptom-based physical examination. But by the introduction of the imaging technology, we have MRI scanning or CT scanning and imaging technology, one can detect cancer or tumor at the early stage. But that early detection is not early, or the treatment procedure is having a lot of problems. What nanotechnology can do? Look here, these are my cancerous cells. These are the pre-cancer cells. These are the normal or healthy cells. If I am going to use a chemical, so you know that cancer therapy, there are two types of treatment. One is chemotherapy, and other one is radiotherapy. So usually chemotherapy is used to kill the cancer cells in the entire system, and radiotherapy is very specific to that local area. So most of the cancer patients are undergoing chemotherapy. So if somebody is taking chemotherapy, what is going to happen is that chemical is going to kill the healthy cells as well as cancer cells. If I imagine that that patient is having some 1,000 or 10,000 cancer cells or precancer cells, by taking that chemotherapy, he or she is going to, his healthy cells are also going to affect. That's why after 2 or 3 chemotherapy, one patient, very healthy patient, become very weak, because his immunity level will come down. His healthy cells are dying. So what we can do? What we can do? Imagine that I have a quantum dots or a nanowire or a nanoparticle modified with some of the chemical moieties which are very sensitive to the cancers or precancer cells. So you take it in the bloodstream, it will selectively goes to the cancerous or precancer cells, keeping all healthy cells alive. That means by taking such nanomedicine, we can keep all the healthy cells alive. So your immunity level will be there and you will be very healthy. Just like a paracetamol you are taking for headache or fever, you can go to school or college or workplace. So people are trying to develop such nanomedicines. You can see that this is one, this green represents the cancer cells and pink represents the healthy cells. And I have incorporated the modified content dots. You can see the content dots or the nanomaterials are situated only at the cancer cells, keeping all healthy cells alive. That means by simple irradiation, it will produce energy and it is going to kill the cancerous or precancer cells, keeping the healthy cells alive. There are a lot of techniques and people are talking about nano devices, and this is a cantilever technology that if I can have a nano cantilever with a single drop of blood, I can detect whether I have a heart disease or diabetics or cancer or things like that. A lot of such discussions and research are going on. And another area is dendrimers. And dendrimers as cancer therapy means it can be used as a reporter, can be used as a single molecule, can be used as a reporter, therapeutic agent, cancer detector, and cell death monitor. So single molecule have multiple functions. So I can use it, and I will skip all these things. And another is nano materials for consumer product. As I told you earlier, for one example is nano zinc oxide and things like that. Lot of industries are there with in the industry for the cosmetics. Another area is nano robots. Nano robots in your body. Maybe after 10 or 15 years, you may have a couple of nano robots in your body. One nano robot is going to look after your heart. One nano robot is going to look after your brain or liver. For example, somebody is having a cholesterol deposit in the artery. My nano robot is going to inject a small brush or inject a medicine to dissolve the deposits. So no more heart attack, no more bypass. So this is going to happen. So nano robots in the medical science and human body is going to be a big challenge in the near future. So a lot of studies are there. I will show. Another interesting thing is nano robots in your for dental teeth. So goodbye to dentist and close-up and Colgate, because my robots are going to work on my teeth. And so this is an anti-fogging material. All these are already in the market. Coming to the space and other aerospace application, one can see that a lot of studies are going on fuel cells, battery, supercapacitor, and things like that. And where nanomaterials, impact of nanomaterials on next generation rechargeable battery. Probably you may know that lithium ion battery and next generation battery, all these things, nanomaterials are widely used. Now, when you are talking about aerospace material, one can have a lot of materials used, generated from nanomaterials. It can be used for EMI protection. It can be used for quality assurance system or resin infusion system, and a lot of things one can use. And so application nanoparticles for the solar cells, a lot of applications are there. And you know that this may be a future material used for the space elevator proposed by NASA. Space elevator reported by NASA. That means a long cable extending from our planet surface into space, a geostationary Earth orbit of 35,786 kilometers. So electromagnetic vehicles traveling along this cable could serve as a mass transportation system for moving people, payloads, and power between Earth and space. The cable must be made up of material with a huge tensile strength over density. Usually, they are looking for nano materials, nano tubes, and things like that. Another interesting thing is, you know, that sun tower proposed by NASA. So if we have one or two such a sun tower, entire energy crisis in the world can be solved. There also nano materials are going to play a lot. And so you can see that net terra plus and things like that. So in short, future space transportation system may be this: a faster, better, cheaper space transportation with the nanomaterials. So it can have an integrated aerospace engine and composite aerosols and lithium batteries and things like that. And my dear friends, with this, I just want to stop here. Again, I just want to tell you that entire this program, the IIST school program, is to motivate the young budding scientist towards science and technology, especially towards space science and technology. And as I told you earlier, my dear friends, please keep a new goal in your life. Not to get a degree, not to get a job, not to have money, not to enjoy the life. Those things are there. Those things are secondary. As I told you earlier, life is something different. Life is something different. If I can define life in the rocket language, we have a GSLV and PSLV rocket, India's workhorse. GSLV is around 300 tons capacity weight. GSLV is around 600 tons. So if you take GSLV, if we consider each student as a rocket. So GSLV is having the height of some 17-story building. On the top, we have a satellite, and satellite is covered with a heat shield. And the entire rocket, so it's out of 600 tons, I could say 550 tons of the weight of rocket is propellants. To carry 3 or 4 ton satellite into the orbit. If you are just like a rocket carrying a satellite, what is a satellite in you? Your satellite is the orbit. Your satellite is the orbit. What is the propellant in you? Your propellant is the knowledge in a wide perspective. Knowledge is the propellant. Imagine that our own GSLV or PSLV is having half-filled propellant, and it is launching. It is going to have a premature death. It should be filled completely, properly filled. My dear friends, if you are just like a rocket and your propellant is knowledge, try to fill maximum knowledge as propellant in you. Try to grab knowledge wherever possible. And these are the avenues. When you are attending a class, when you are reading a book, when you are doing a practical, when you are doing a project, when you are observing something, when you are interacting with somebody, all these avenues are the avenues to grab knowledge. Try to fill maximum propellant in you so that you can fly high. As I told you, your satellite is the goal in life. As per Kepler's law, if you keep this satellite in the right orbit, it will orbit just like that. So if you can put your satellite, the goal, your contribution, you will be remembered forever. And your satellite is having a heat shield. What is a heat shield made up of? Your heat shield is made up of lack of confidence, lack of determination, lack of focus, peerism, laziness, etc., etc. Try to break it. Try to break that shell. Just like a cocoon. Cocoon is having a shell. It is struggling to break the shell and coming out as a beautiful butterflies. My dear friends, you are just like a cocoon. Try to break the shell. Shell made up of lack of determination, lack of focus, lack of hard work, laziness, peerism, all sort of things. Break it. Come out as beautiful butterflies. Fly. And this is the real goal in life. And you will be remembered forever. So work for that. When you type your name should appear for thousands and thousands of times. Your contribution should be remembered forever, just like Raman, just like Einstein, just like Newton, just like Vikram Sarabhai, just like Homi J. Baba, just like Abdul Kalam sir, and so on. So wish you all the best. Thank you so much. So my talk is over. Thank you so much. Hello?
Thank you, sir.
Okay.
Thank you for that wonderful lecture.
Somebody from the Sargakshetra is there?
They are there.